Welcome to Marzouk SolidWorks Tutorials and Designs. Today we are going to deal with this project. It's a robotic arm project, 6 degree of freedom. I made all of it before, and I will upload it on GrabCAD. You will find it on GrabCAD on my account on GrabCAD. You will find the files, all the files, and the assemblies and this all these files, and it's all free and open source. It's meaning that when you open any of them you will find all the dimensions and you can edit it. And I also will upload IGS file of all this robot, so that if you don't use SolidWorks you can open the robot and watch it. And also I will make tutorials on my channel on YouTube. To get to my account on GrabCAD, go to GrabCAD, then go to Engineers. GrabCAD is spelled G-R-A-B-C-A-D. Go to Engineers and type Marzouk, search. This is my account, and you will find this project under projects. This is my already found projects, and you will find it there beside this projects. And also I will upload the tutorials. To find the tutorials you can also go to YouTube and search for Marzouk SolidWorks, SolidWorks tutorials and designs. You will find my channel. This is my channel, Marzouk SolidWorks tutorials and designs. Go to my channel and you will find playlists. Go to playlists and you will find this project there. I will upload its videos. I tried to make all videos and upload them in one time, but really it's a very big project, so I will upload these videos separately. To make sure that you will find the videos, go to my channel and hit this button, subscribe, so that the videos appears on your YouTube page. Or also after you subscribe, you can hit the ring beside the subscribe button, so that you get notifications there when I upload new videos. Also on GrabCAD you can follow me, so that when I upload new parts or tutorials you will get notifications. This is the project. It's a complete 6 degree of freedom robotic arm. We can watch some photos of this project. It's somehow detailed, and all dimensions and and also error notes. I will talk about it. We will discuss all of these details if Allah wishes. Of course, the real robot is not as simple as this. By the way, this is simple. This is not the most complicated thing. This is a real robot. It's very complicated to my project, and all of its drive, or you can say most of its drive, are harmonic gearboxes, but I used simple planetary gearboxes. I love this type of robots. and watched it for a long time, but I didn't disassemble any one of them. I just imagine about the mechanics in it. And again, it's this project is not the real one. The real one is most complicated than this. Let's go to SolidWorks. You will find, or we will teach with each other, or we will learn with each other how this robot works. This is the first degree of freedom. Just moving this moves all these parts. It's based on simple planetary gearbox, but again, this is not the real one. The real one don't work like this, but it is, you can say that this is simple. Again, for the second axis, I will stop this there, or will suppress this, so that I can move this shaft, and the shaft moves all the mechanism like this. Also, we'll learn with each other how to make something like this. I love this honeycomb shape. It's not found in the real robot, or in this specific real robot, but I made it. For axis 3, this is the mechanism which moves it. Again, this is a simple mechanism, a very simple mechanism like this. Very simple mechanism, and we will learn with each other how to make something like this. For the last 3 axes, this is axis 4. This is how axis 4 works. Moving this shaft moves this gears there, this, and afterwards this. For axis 5, now I will suppress this relation. For axis 5, moving this shaft, this is axis 6 or what? Okay, moving this shaft will move yes, this is axis 5. This is axis 5. This rotation is axis 5. For axis 6, again I will suppress or unsuppress this relation. For axis 6, and I think this is the most beautiful one. For axis 6, moving this shaft, again I need to suppress this relation. I can hide some of these. Again, moving this gear can move this pulley, and moving this pulley drives this right angle this right angle drive there, and this right angle drive move this planetary gearbox there. We will learn with each other how to model such a mechanism. I think it's simple, but it may take long time. So I recommend I advise you to subscribe my channel so that when I upload a new video, you can get it at the same time. And again, you can download the files from my account on GrabCAD. The same channel and account on GrabCAD has the same name, Marzouk SolidWorks Tutorials and Designs, and to be continued. Welcome to Marzouk SolidWorks Tutorials and Designs. Today we are working on this project. This is a complete 6 degrees of freedom robot. This is the first axis, this is the second axis, and this is the third, this is the fourth, fifth, and sixth axis. If Allah wishes, we are going to design together all this robot, all these parts, and learn how to assemble it. It's uploaded now on GrabCAD, on my account on GrabCAD. My account is called Marzouk SolidWorks Tutorials and Designs. We will design every part, but at this video or tutorial, we are going to ask the first question, which is from where to start. From where to start? If you started from a wrong side, there will be many problems, and perhaps you can't complete the project. So the question is from where to start in any project or in any mechanical design. In my opinion, I start always from the place or from where or from the part which is the most movable part. The most movable part. We have fixed parts and movable parts. I start from the most movable part, the part which moves at the most degrees of freedom in any application or in any design. I start always from the most movable part. Why is this? I start from the movable parts because if I started from the fixed parts and put some dimensions there, I will be forced to some dimensions in the movable parts. But when I start from the movable part, something like this, I know how to carry it on the next axis. When I start from a part like this or from place like this, I know that this is the most movable part. I know something like this. So I know how to carry this. How to carry this on the other part. So I design a part like this or an assembly like this. After which I know how to carry this on the next part, which will be something like this. When I design this part, I know how to carry this on the previous part or on axis 3, for example. But if I started from there and I put these dimensions, let's say from here to here, I will be enforced to put the next axis in this area. If I couldn't do this, there will be problems. But if I started from this part, from here, I have the freedom to enlarge this part afterwards when I am coming to design this part. It's also related to stresses, which means that when I design this part, I can guess the forces which will appear there. So I will design this part to carry these forces. But if I started from here, and put some dimensions, maybe afterwards I discover that the forces which comes from there, this part will not carry it, or will not can to support this force. But if I started from there, I can guess the forces which will appear there, so I can design this part which will carry this, so that it can carry these forces. So it's a very important question, which is from where to start. In this design we will start from there, designing part by part and making assemblies. After we complete this axis, which is, let's say, 6 axes, we will design the axis 5, which rotates here, and afterwards axis 4, afterwards axis 3, which moves there, afterwards axis 2, which is there, afterwards axis 1, which is there. This is axis 1. So I preferred to start with this video about from where to start. This is not just for this design, but for all designs. For all designs, we must start from the movable parts. For example, let's look at this mechanism there. This is axis 6, and this is axis 5. Let's look from there. If you wanted to design something like this, let's say that we want to design this right angle mechanism, something like this, and this is planetary gears. Again, if I want to design something like this, from where to start? For me, or in my opinion, I started from this shafts, the most movable parts, something like this. I design something like this, and I choose bearing to be located there and there, such as this bearing, and this bearing. I designed these bearings on this shaft. Afterwards, I can design this this parts. But if I started from there, and put dimensions there to carry some bearings, afterwards I I may discover that this bearings will be so small for this shaft. Afterwards, you may discover that this shaft, this dimension will be let's say 5 millimeters. It will not be logic to put 5 millimeters there. Afterwards, this gear will be 4 millimeters in diameter, so you will not be able to put any teeth there. But if I started from there, I know that let's say this gear will be 30 teeth or 24 teeth. Afterwards, I can guess that this diameter will be, let's say, 26 diameter, so this will be, let's say, 30 diameter, 30 millimeters. This will be, let's say, 35 or 40. So I will put my bearings there. Afterwards, I will know the outer diameter of the bearings. If I know the inner diameter of the bearing, I can know the outer diameter from the catalog. Afterwards, I can go to this part and start from there. That this diameter is, let's say, 55. This diameter is, let's say, 72. Afterwards, I can imagine the part which will carry all this dimension. It will be by logic will be bigger than this. This will be about 150 or something like this. So it's one of the most important questions in this project, or in any project, which is from where to start. If I wanted to design some planetary gear like this, I will start from there and from the outer ring or from the outer gear. Afterwards, I can imagine or I can calculate this diameter of this gear, but not the opposite direction. I can't start from the outer gear, afterwards this gear. So I calculate this gear. I find that this gear will be 12 teeth or something like this. It is not logic. So I start from there and from the outer. It's a very important question. So I prefer to make a video before starting in the project to discuss this question. In the next video, we will start designing first parts, which will be the last parts, or you can understand this now. The first part will be the last part in the project. So if you imagine that this is the first part in the robot, you can know that we will design this at the last video. We will design this part at the last video. Thanks, and wait for the next tutorial. Thank you. Welcome to Marzouk SolidWorks Tutorials and Designs. We are now working on designing this robot. It's uploaded on GrabCAD. All parts are uploaded and all parts are tree free. It means that you can open any part and show dimensions and edit the part. And we are now making the tutorials for this project. I made the first tutorial, which is introduction. The second tutorial was about from where to start, and we knew that we will start from here and back to the base, and we discussed this question in the previous video. Today we are talking about the components, how to prepare your components, which is gears and bolts and bearings. In this project we have many gears and bearings and bolts. And I will today we will discuss how to prepare these parts. Firstly, you can find these parts in the toolbox, but I don't prefer this. You can go to let's say the German standard DIN and go to let's say power transmission and gears. You will find these types of gears, but I don't like to insert or import these parts from here to the assembly directly, because this may cause some problems. By experience you can know that this may cause some problems, so I have my own idea. I open an assembly file, empty assembly file, and go to library from here, and again go to toolbox from here and choose the standard. I will choose the German standard because this part or this robot is KUKA robot, which is a German company. It's very famous for making robots. You can say that it's the best. You can say it's the best in the world. I didn't use any of their robots or any of other companies, but it's known to be one of the best or the best. So I prefer to use the German standard DIN. Go to power transmission, gears, and here is my method or my technique. I insert this spar gear like this in the assembly file. You can change everything from there. You can choose module, number of teeth, pressure angle, all of this. Okay, now you press escape. This is an assembly file, but we don't make sure that this part is in the origin, so we want to move this. If you want to move it, you will not be able to move it, so right click and float this part. Now it can move according to these plates. Now I will add mates. Plane 1 is the front of the gear, plane 2 is the top of the gear, plane 3 is the right. So I will make plane 1 coincident with front, okay, plane 2 coincident with top, okay, plane 3 coincident with right, okay. Now I am sure that this part is in the origin. Now I will save this part. I will make a new folder. This numbers is based on 17 is the number of year, and 03 is the number of this project. I have made or I had made 2 projects, space shuttle and lathe gearbox, and this is the robot. This is the 3rd project in this year, 2017, so I called it 1703. Now I will save this part as gear generator spar. Okay, this is an assembly file. Okay, now I will right click there and edit toolbox component and change the modules as I like. Now I have or I need all these gears. This is module 2, number of teeth 16. This is module 2.5, number of teeth 24, and so on. So let's make something like this. This is module 2, number of teeth 24. I think its width is 30. Okay, now I will save this. Again I will edit this part, edit edit toolbox component. Module 2, number of teeth will be 24. Pressure angle 20. Face width will be 30. Nominal shaft diameter, this is 10. Okay, no problem. Okay. Now this is an assembly file. The most important step is to save this file as part, all components, and I will call this gear M2Z24. Okay, now this is part, not an assembly. Okay, thanks. Now I don't need anything more. Go to this folder. Now I have, this is the assembly file and this is the gear. Now this part is separate from the library, and here is the point. This part is separated from the library. If I made any changes there will be no problems. But if you used parts directly from the library and you try to make some changes or make holes or key or something like this, it may cause problems afterwards. Again, I said that this is a part, it's very ordinary part. Now I can go here and make a sketch, let's say 30 or 24 millimeters, and extruded cut with 30. Now it's a very simple part. You can make what you want, make holes, make anything. You can add chamfers, something like this, and you can edit this part. But of course you will not be able to edit the number of teeth or the module or this type of things, but we will generate all the gears which we will need. We will generate all these gears, or you can go to GrabCAD and download the files. You will find all these files, but I prefer to practice. I advise you to practice and make all these gears. We will make every gear in its step or in its stage. Again, this is our project. In every stage, we will make our gears. This is all of these are gears. There are internal gears like this. It's designed with the same idea. I made a new assembly file and go to there and insert internal spar gear. Okay, sorry, again internal spar gear. Okay, the next step is to float this part. The next step is to add mates. Plane 1 with front. Okay, plane 2 with top. Okay, plane 3 with right. Okay, and I will save this part there. I will call it gear generator internal. This is an assembly file. Okay, this is an assembly file. Again, I will edit this part and change this type of data as you need. Here you can find this, that we need let's say a gear like this, gear internal module 3, number of teeth 160. Again, you can go to there, module 3, number of teeth 60, pressure angle 20, face width let's say as you like 60, outer diameter let's say 500 or 600, something like this. Okay, and save as part. Again, we finished editing. Now we will save as part. All components. I will call this part gear M or internal gear M3Z160. Okay. Now I can go to this assembly or this part. Now gear, now this part. Now I can make edit here. I can add let's say 540. Now I can extruded cut let's say 20, flip side to cut. Okay, I will make something like this. Now I can go here and add something like this and add hole here, let's say 14. Now I made a hole like this. Now I can make circular pattern of this hole about this diameter, let's say something like this, and so on, as you like. Okay, so this is the method of making internal gears and gears. Again, the thing which you may need also is bearings, something like this. Also, you can find bearings in SolidWorks library, but I prefer another method. You can go to SKF. It's a famous bearing producer or manufacturer. You can use or choose your country. Now you can go to this search box and type the number of bearing which you need. Again, search. This is the gear. The bearing. Maybe afterwards I make a video or a tutorial about bearings. This is the bearing. Now you can find CAD model here. You can choose the program which you use. I use SolidWorks. Okay, and download. Your part will be downloaded. Okay, download. Okay, go to the part where you downloaded the part. Where is the part? This is the part. I think this is the part. This is the part. Okay. This is the part. I will extract this file. This is the part 6004. I will take this file and go to SolidWorks. I will put this here, not here, here, between the commas, here. Okay. SolidWorks will generate the part. It may take seconds. It's working now. This is the part, and this is an assembly. This is an assembly. Again, we will use the same method. We will save this assembly as part, all components. I will call this six is roller bearing, deep groove ball bearing. 4, if you multiply this by 5, this is the internal diameter. 4 by 5 is 20. The internal diameter is 20. And this number and this number, maybe I will make a detailed video about bearing afterwards. Okay, see. Now SolidWorks will generate a part. Now you don't need this assembly file. Go to our folder again here, and we will find this part. Now this is an part, not assembly. Multi-body part. Every body of there, this is a body, this is a body, and it's all is a part. Now you can drag and drop this part in your assembly easily and simply. You don't need or I don't prefer to use the library of SolidWorks. There is the library, there is SKF bearings, roller bearings. This is a bearing, but I don't prefer this type of bearings. Again, the last thing is the bolts. You can draw the bolt if you like this. I draw all my bolts, and you can also drag and drop them from there. You can also make assembly file, empty assembly file, and drag and drop the bolts which you need. This is a hexagonal bolt like this. Okay. Now you can float this part. Again, you can add mates. Plane 1 with front. Okay. Plane 2 with top. Okay. Plane 3 with right. Okay. This is the bolt. Now I will save this as here. I will save this as bolt generator. This is an assembly file. Okay. Again, I will edit this part, edit toolbox component, and change all this. Let's say M10 length. Let's say 60. Okay, 26. You can use schematic, something like this, or you can use cosmetic, something like this. I prefer schematic. Okay, something like this. Okay. Again, I can save this as, now I can save this as part. M10 length 60, and save this as part, all components. Okay. Now this part is detached from the library. Now this bolt is detached, is not linked to the library. So if you use it, you don't have, or you will not face the problems of the library parts. Myself, I made my own library. This is my own library. This is my library of bolts. This is M10. this is hexagonal bolt, this is Allen bolt, and this is the nut. I made my own library, and also from gears or bearings. This is linear, this is radial, linear, something like this. Something like this. I downloaded all these parts and saved them as parts. This is radial bearing, all these types. This is Y bearing. This is SY bearing. Something like this. I downloaded all these parts and saved them as parts. I downloaded them as assemblies and saved them as parts. Now you can use them in your designs easily. I don't prefer to use assemblies, or I don't prefer to use library parts. This video is very important because during the whole project you will need gears, you will need bearings. Again, this part also is made with the same process. During the whole project you will need bearings. This is gear. This is coupling. You can also download the coupling from the manufacturer website, or I designed the coupling. This is internal gear. This is gear. Again, this is gear. This is internal gear. Again, gears, internal gears, and bolts, and etc. So this video is very important before the start. Before you start your work, you will need to prepare all your components. Components here mean gears, bearings, and bolts. Thanks for watching, and wait for the next videos. Welcome to Marzouk SolidWorks Tutorials and Designs. Today we are going to start the design of each part of this robot. We will start with this part. It's a very simple part. How to design such a part? Let's open a new part. It's a very simple part. Going to front and drawing the profile. It will be revolve. It will be a revolve, so we will need this center line. Firstly, we can say that all these parts, all these segments are equal. Also, this segment and this segment are equal. All of them are 1 millimeter. Okay. This dimension is 14 and this dimension is 35. This dimension is 10. The outer diameter is 200. This diameter is 92. This diameter is 160. In SolidWorks, if you make a dimension between any line or point and a center line and going to the other side, SolidWorks will show double this value. Will double this value. This is the radius and this is the diameter. Okay. Again, with the same method, if you choose this line and this line, this is the angle. If you go to the other side, it will not show the double of the angle. So press shift and go down. Again, press shift and go down. And these are the dimensions of these. This value is 12. So we get the fully defined sketch. For this area, I will not make this again. I make this for the first time, just this time. But all the parts which will need this feature afterwards, I will not make this feature again. Now we will make revolve. I mean this recesses. I make this recesses to help when you try to grind this area and this area. I don't want the grinding wheel to touch this area, so I make this recess, but afterwards I will not make this again. I make this just for the first time. It's an educational project. This is an educational project, so we may make something like this. I mean that I make something in one part and make another thing in another part. But if you are going to manufacture something, you just use one method which you think it is the best. This is the main feature, which is revolve. Afterwards, I will make 4 rectangles. This is rectangle number 1. This is equal, and this angle is 30. Also in SolidWorks, if you have a line, just a line like this, and want to add a dimension to it, you can click on the line, then click on the start or end point. You will have this triad. Choose one of these arrows and add the angle. Again, click on the line, then click on this point. You will have this triad. Okay. This rectangle will have the dimension 54. Again, I will make another rectangle. Again, I will add equal there. Again, I will add 30 degrees there, and will add this dimension to be 72. Again, I will make another rectangle. Here is equal, and this line is 96. The last rectangle will be also inclined with 30 degrees. You can say that this line will be parallel to one of these lines, and here is equal, and this dimension is 128. Okay, now we have 4 dimensions: 54, 72, 96, and 128. Okay, now I will add holes or tabbed holes. Going to features, going to hole wizard. Firstly, I will choose the standard to be DIN, DIN. I will choose M8, and the near side countersink will be 9. The position will be on this face, on these 4 points. This is 1. Sorry, on these 4 points. This is 1. This is 2, 3, and 4. Okay. Again, I will go back to this sketch and remove this point. Okay. This is the M8, but I don't want this tabbed hole to be through all like this, so I will decrease this depth. Let's be 8 by 10 or something like this. I don't want this hole to be through all. Again, I will choose the same command. Now I will use M10. The countersink will be 12. The position on this face. On these points. Okay. Again, making sure that there are no through holes like this. Again, I will decrease this value. Like this. The last holes, I will make them small holes here. I will make them M6. M6. The countersink will be 7. Position on this face on these points, and I will make them through holes. Okay. Now I will explain why I made these holes through holes. Now I will go to options, document properties, detailing, and remove this cosmetic thread and show shaded cosmetic thread to be simplified. Now I will try to make the holes which will carry these bolts. You can make them with counter bore command, or with just holes, just circles and holes. I will use the first method. I think in this design I made these holes on, again sorry, this rectangle is 72. Okay, no problem. Okay, again going back to this part. I think this holes M8, I will delete this, and I will delete this. For M10 I will delete these holes, and add holes there. Okay, and M8 will be on this rectangle. I think this small rectangle may have let's say M6 or M5 holes. Okay, now going to make the counter bore. This is the counter bore. I will choose counter bore for M6, and the hole is through all. You can add countersink, near side countersink, let's say 9. The position, let's say that it will be 1 point here. I will add a center line from this origin to this point, and this is vertical, and this is 86 or 90. Just I want to make sure that there is no problem there. Something like this, okay. By the way, you must go back and choose this to be socket head, hexagonal socket head, something like this. The near side countersink may be 14. Okay. Or 16, okay. Something like this. Now I will add a circular pattern of this counter bore around this cylinder, about 12 instances, and I can skip some instances. Let's skip this one, okay, and 3 and the 4th, and 3 and the 4th, and 3. Okay, now we have 9 counter bores. Okay, On the other side, I will make a pin there just for guiding. There I will make a pin. This pin will be just a circle, let's say 10 millimeter in diameters. I want to make these two center lines and make them equal, so I don't need to put a dimension there. And also I can put two center lines there and make them equal, so I don't need to add angle. Also I can make the other three holes. I can make circular pattern about this point and make three. This point must be sent back to there, and making a hole, let's say 12 millimeters in depth. At last I need to add a hole, M6 hole, at this face. I will show the hidden lines and put a point there and a point there and a point there, and making this through all. Why do you make this? Again, M6 through all 7. Okay. Again, why did you make these holes? I made this because when I put this or make assembly like this, and I wanted to pull this out, I will not be able to pull this out from this. I will not be able to pull this out from this, so I made this idea. What is the idea? This is the idea. I made this hole, tapped hole, M6. When I want to pull this out, I just put an M6 bolt there and draw this down, so it will pull this red part to get it out from the assembly. Again, this is an educational project, so you may have or you may face different methods or different ideas. But if you want to make this project for manufacturing or real manufacturing, you will have you don't have to make many methods. You just need to choose one method which is the best and use it for all parts. But in an educational project, you will find me using a method now. In the next tutorial, I will use another method, and so on. So this tutorial was just about this part. This is the first part. In the next tutorial, we will make this part and make the assembly and add the gear here. Thanks for watching and wait the next tutorial. Thank you. Welcome to Marzouk SolidWorks Tutorials and Designs. Today we are going to design the next the second part of this robot. If Allah wishes, we are going to design all these parts. In the previous video we make this part. Again, you can find all the parts on GrabCAD, on my account on GrabCAD. My account is called Marzouk SolidWorks Tutorials and Designs. You can find all these parts, but I prefer that you design every part with me and make the assembly yourself and so on. It's an educational project. This is an educational project. We are interested more in the educational part of the project. Again, we are designing now this part, the second part, this. Firstly, I want you to have a look from there. To understand the function of this part, we have this face and this face and this face. Between them we will have a frictional plate. In the real design of this robot there are no friction plates, but we have simplified this as we can. In the real design there are harmonic drives or harmonic gearboxes. If Allah wishes, I may explain what is the harmonic drive in another project, but just for simplification, in this project we have this simple parts. Now I want to design this part. How to design this? Making a new part. I will open a sketch there. I will add these two center lines and will draw the section or half the section of this part, which is this. I will draw this area again. And I will add the dimensions. This is 9, this is 12, this is 1, this is 9, and this is 2. For diameters, I made this center line to use it for diameters. This is 200. This is 188. This is 172. This is 150. This is 160, and this is 140. Now this is this fully defined sketch. I can add a dimension there just to make sure of my dimensions. Again, this is 9, not 7, 9. Okay, this is a driven dimension, which is in gray. Okay, now I will make revolve about this line, and this is the main feature or the main body. Now I will make the holes which will, this is the first part. I will save this. I explained this part in the previous video. For the part in the project, if you downloaded it from GrabCAD, you will have this paths. I just make it as cosmetic or just for appearance, to show the user that there are a relation between this 4 and this 4. Again, how could you make this? It's very simple. You can draw a rectangle between these 4 holes, and you can, from features, you can make swept cut. Choose circular profile and choose the profile diameter to be 1, and the path is this. This is very simple, starting from I think the year 2016 in SolidWorks. You have the ability to make this simple feature. Again, I can make a rectangle there and making swept cut, circular profile on this. Again, I can draw a rectangle between these holes, and now making a swept cut, circular profile on this. It's just a cosmetic thing. Now I wanted to add the holes which will contain this M8 bolt. Again, I said that this is a tutorial, and the main object is educational object. So I will use many methods to make the same command. Now I wanted to make 9 holes there, so I can add a polygon. I will choose the number of lines to be 12 and circumscribed circle like this. This circle will be 180, and this point and this point are vertical, and exit this sketch. Okay, how to use this sketch? Now I will go to Hole Wizard and choose M8. I choose the tab, straight tab, and M8. The countersink is 9. The position on this face, and now I can use this polygon as a reference. In the previous video, I used another method. I used the circular pattern. In the previous video, if you remember, I used a circular pattern. Again, this is an educational project, so I try to use many methods. Again, if you noticed, I changed this value to 90 because this value there is 180. This value is 180. Again, using the same polygon, I will come here and making a circle, let's say 10 millimeters, and there and there. Again, I will say that all these circles are equal, and I will make this hole just to use it as a guide. Saving this, you can save it as you like. I already have my parts, so I will not save this, or I will not be interested in saving them with codes and something like this. But if you wanted to add code, I will add 1703. 17 is the number of year, and 03 is the number of this project. And I will add, let's say, axis 6, plate or ring 2, or plate 2, as you like. Again, I saved this on the desktop. Of course, you will not save on the desktop, you will have your own folders. And by the way, if you wanted to change the name of this part, don't change it from here. Don't make like this. Don't make rename from here and change from here, but open the part and change from here. Click, wait, and click, and change it from there as you like. When you save, use update where used references. Okay, and thanks. This is the right method to change the name or to rename. Now we will make this gear. In video number 2 or number 3, I explained how to make such gears. We made parts which we renamed as gear generators. You can go back to this video in the same playlist. I explained in this video how to make gears and bearings and bolts. Now I will make this gear, internal gear internal module 1, number of teeth 128. You will just have to add this cut with 140. Again, I explained this before. You can go back and watch this video. The last thing is to add is to make assembly from this. I will choose the fixed part. Let's say this is the fixed part. I will make assembly from it, from file, make assembly from part. This is the part. That's a 6 plate 2. Okay, and I will drag and drop this part to the assembly file. I will add mates. These are concentric, these are concentric, and these are coincident. Okay, and I will drag and drop the gear. You can also use the files from GrabCAD directly. Again, these are concentric, these are coincident, and the front of the gear coincident with the front of the whole assembly. Now we have this assembly. By the way, this gear will be mounted by heating. You will heat the outer ring and cool the gear, and after the gear and the ring will go back to the normal temperature, there will be interference between them. It's a common method with gears, such as the gear on the motor, on the car motor, which is called flywheel gear. which is connected to the initiator. Now you have to add the bolts and the pins. Again, in video number 3 I explained how to generate the bolts. Now I will use this M8 bolt. I made many configurations of it. I will add mates, this and this face will be parallel to the top. I like to add or to make all my parts fully defined. This is going out. Again, we can go to this part and edit this. Okay, I can move this face directly from direct editing. Move face, translate. I will choose this face and the whole similar faces, and I will move them in X axis. Something like this. Direct editing commands are very useful. Now this bolt is now there. This is the bolt. I may need to make it longer. I will change the configuration. I think this is good. I think this is good. Okay. Now I will make a circular pattern of this component around this face. I will use 12 bolts and instances to skip. I will skip this instance, leaving 3 and delete this, and leaving 3 and delete this, and leaving 3. Okay. Okay. The last thing is to add the pins. There. These pins are used just for locating. This diameter is 10. Okay. It's a very simple part. You can add a circle 10 extruded by 20 and add a chamfer there by 1. Okay, and save this as you like. Okay, and add this part there. Thanks. Again, I will hide this part and I will add this pin there and this face there, and the front of this pin will be parallel to this front, the front of the part. Again, I will add a circular pattern, or you can add them manually. Again, this is an educational project, so you may have to add them manually just for practice. Okay. Show hidden components. This is hidden. Exit show hidden. Okay. I think this part is now complete. Okay. Again, you have all these parts directly if you downloaded them from GrabCAD, but I advise you to redesign them. The practice is very important for everyone or anyone who want to make designs. The practice is very important. Now we make this part again. This is the part. By the way, all the mechanisms are working in this project. It means that if you move this, all the mechanisms, all this and this right angle mechanism and this belts and all of this and this Y joint are working until or to this shaft. It means that if you move this part there, you can notice that this shaft moves, all this drive moves, and if Allah wishes, I am going to explain all this mechanisms. It may take time, but it's very interesting project, and I hope that everybody will get interested with this project. Now we make this part. I will hide this. The parts which we designed, I will hide them just to concentrate on the next parts. Okay. In the next tutorials, we are going to design this part there and this part also. In the next tutorial, we will design the right angle gears and the planetary gears there. There are planetary gears there. Okay. Thanks, and wait the next tutorials. Thank you. Welcome to Marzouk SolidWorks Tutorials and Designs. We are now designing this robot. And in the previous videos, we explained how to design these parts, and I hide them. Now I am going to design this part. It's very important. It seems to be complicated, but it's very simple. How to design this? I will start a new part, sketch on front, and I will draw this profile. Let's add some dimensions. This is 10, this is 14, this is 6, this is 15, this is 9, this is 1, this is 14. Let's add some diameters. This is 48. This is 168. This is 172, and the outer diameter is 200. Again, this diameter is 55. This diameter is 64. This diameter is 72, and this diameter is 130. Now I will make a line there and break this. I will make two center lines. This is vertical and these two center lines are equal, and this is 10 and this is 4. Again I will continue to draw this part. I will make an arc from there to there. This point is on this line. This line is 10 millimeters. Again I will make another line like this and another arc like this. These two arcs are concentric. The distance between the center of these arcs and the origin is 106. This line is 30, and I will take this line like this. I will delete or trim this line and this line and these two lines. Now we have the complete dimensions of this part. Now I will make a revolve about this line. Okay, let's call this part the ball. By the way, when I was designing the first robot, this part took a lot of time, because I didn't make it once. I didn't make it all in one time, but I made it part by part. I started by making this area. Afterwards I made this part. So if you downloaded the files from GrabCAD, you will find that I draw the part in another way. I draw this part firstly. Afterwards I make this holes, and afterwards I made this part separately. I made this sketch separately. But I think after one trial we can make the part in a simple way. Again, on the top I will draw a line like this, center line there. I will mirror this line about this. This distance between the two lines is 180. I will use this to cut this part. Again, I will draw a line there. The distance between this and this is 25 millimeters. Afterwards I will close all this contour. any dimensions just to close the contour. And I will make through all cut something like this to have these flats. Again, going back to this design, you will find that I made this in another way. This is the first sketches, and this is the second sketch. No problem. This is an educational project. It's good to have many methods or methodologies. Again, I have to make this hole and these two holes. Again, on this face, I will draw a circle 70. The depth of cut, let's say 50. Notice that the part is hollow. Again, on this face, I will make another circle 100, let's say also 50, and this face also 100 and extruded cut by 50. This is the shape. Afterwards, I wanted to make this bosses. These bosses are on a circle. Which is here. I will draw a polygon, 6 sides like this, and I will choose the circumscribed circle, something like this. This circle is 76, and this line is vertical. And I will leave this circle or this sketch as it is. Again, I will open new sketch there, and I will make circles there, just 4 circles. All of them will be equal, and all of them are 20 millimeters. I will extrude this by 24 millimeters, and I will add fillet of 3 at this circle and these 4 circles. Okay, now I will make M10 the depth is 20, the depth of hole is 24, let's say this is 22, and this countersink is 12. The position on this face at the center of all these circles. Okay. Again, I will make another hole M16. I will make this, let's say 35 and 38. This hole is 18. Position on this face at this point and at this point. I will take a section just to make sure that there is no problem there. So I will decrease this hole, let's say 24 and 26. Something like this. I think this is enough. Okay. Again, on this face, I will make other holes. It's M8. This is M8. M8. Okay. Again, I will use hole wizard. M8. No problem about this dimension because it will be ended in the air. The position is there. I will make just one, and I will repeat this with circular pattern. This line is vertical, and this dimension is 54. Okay. This is the hole. I will make another hole there. The diameter is 12 and the depth is 4. Now I will make a circular pattern of these two features, this and this, about this cylinder, let's say 12. I think this ball are finished now. This is the same as this. Okay, something like this. Okay. Again, all these holes will be closed afterwards. If you looked at the the complete design, you will find that all these holes will be closed afterwards. Even this. A part like this must contain oil for lubrication. If you looked inside this mechanism, you will find many gears which need lubricating. Let's take a section from there. All of these are gears and bearings which will need lubrication. In the next video, if Allah wishes, I will make the gears. These gears, by the way, this mechanism is very beautiful to be learned. When I started designing this design, I made this firstly. I made these two shafts firstly. If you went back to the video number 1, we discussed this question, which is from where to start. And we said that we start from the moving parts. Afterwards, after I start with this part, I can choose the bearings. Afterwards, I can make the part which will carry these bearings and these shafts. But just for simplification, I started in the tutorial with the case. But again, if you are designing this part from the first, it's better to design the shafts firstly. Afterwards, you put the bearings on the shaft. Afterwards, you design the housing which will carry all this shaft and bearings. In the next video, if Allah wishes, I will discuss how to design the shafts and the gears and this part. Thanks for watching and wait the next tutorial. Thanks. Welcome to Marzouk SolidWorks Tutorials and Designs. Now we continue the design of this robot. In the previous tutorial I made the ball which is here. This is the design. In the previous video I made this ball. Today I am going to design this shaft. I am going to design these two shafts. They are the same but configured. I mean that I designed just one shaft and made configuration of it. I have two configurations. The start of this shaft, I started with making a gear. Go back to video number 1 or number 2, which deals with how to generate these gears. Afterwards, I made a gear like this and started from this gear to make my part again. This is the gear which I generated. This is just the gear which I generated. So I may save this as a copy for tutorial and show you how I completed. Again, this is the file. Again, there are problems there. I will go back to this assembly. I just want to replace this part. Replace component. I will replace this with the first one, which is this. Okay. Now the problem was solved. This is a common problem which may happen if you changed a name of a component. By the way, I don't like to change the parts names, but just for educational purpose I made this. But in my work I never change the name of the part. If you wanted to change this, you can change this from the tree. but saving apart or save as or this comments, I hate this comments and it makes many problems. Again, going back to this part which I made just for educational purposes, how could you complete this part? Again, how could you generate the part? You can go back to video number 1 in our playlist to show how to generate this gear. It's very simple. Now I will work on this part. From direct editing I can delete face. I can delete this face, delete and batch. Okay. This is the first step. Okay. Now I will make a revolve on the front. Revolve like this. Now I will show you why I made all these steps. I will make a center line there. The first diameter will be 26. Okay. The second diameter will be 30. Then 34, 35, 52, 40, and 30. Maybe I increase this 40, let's say 48. Okay. Now I am dealing with the length. This is 10. This is 15. Or maybe I will delete this 10 now. Maybe this is 7.25, and I will show you why this dimension. This is 17. This is 1775. Again, I will delete this number, this dimension, and I will add 80 there. Again, this dimension is 5, and this is 8. Okay. Now I will make a revolve like this. Okay, this is the first step. The second step is that I want this shaft to be something like this. How could you make this? Now it's very simple. How could you make this? On this face I will make a sketch, and I will convert this face. Okay, this is a sketch. Okay, now on the front I will make another sketch. I will say that this arc is 15, and this is 10. Okay, now I will make a swept cut. I will make this profile to go through this line. This made this shape. Okay, now I will make a circular pattern of this swept cut about this cylinder. The number of teeth, it's about I think it is 24. Okay, and this is the shape. I can add chamfer there, let's say 2 millimeters. Okay, now I want to make a hexagonal there. This line is horizontal and this dimension is 40. Now I will make extruded cut, flip side to cut the outer side, and the end condition is up to surface, which is this surface. And this is the result. Going back to the main part. This is the tutorial part. I want the other one. Now I need to add this hole or this tapped hole, M12. Again, going there, and I will make hole wizard. Choose the size to be M12. Let's say this is 27, this is 30, the countersink is 14, the position there at this point, and okay. Now this is the original part, and this is the part which we made for the tutorial purpose. Again, how to make the other configuration? Going to configuration, I will add configuration, right click and add configuration. Let's say configuration number 3. On this configuration, I will start a sketch on the right, and I will make a circle, let's say 28, and will extrude in direction 1, let's say up to this area, let's say 40 millimeters, and in the second direction, let's say 20 millimeters. Okay, so this is blind now, or solid now. There are no teeth on this face. I will make another hole, also M12, the same numbers on this face. So now I have two configurations. The default configuration is with the teeth, and the second or third configuration with this end. How will you use this configurations? Going back to this mechanism, these are the two shafts. One is used with the planetary gear, and the other is used with the timing belt. In the next video, we will learn together how to design this right angle drive or gear drive, and also we may learn how to design this planetary mechanism there, like this. Of course, this moves the axis 6 again. Going to the main design. This is axis 6. I will show the components, the hidden components there. This is axis 6. This belt moves this timing pulley, and this timing pulley rotates and it moves these gears through this right angle drive or bevel gears. This motion came from there, from this shaft and from this motor. If Allah wishes, we will continue to explain all these mechanisms, all these parts, and all these gears and universal joints and bearings and all this type of parts and mechanisms. Thanks for watching and wait the next tutorial. Thank you. Welcome to Marzouk SolidWorks Tutorials and Designs. We are now working on this project. This is 6 degrees of freedom robotic arm. In the previous videos we made this part. We designed this part and all these parts up to this part. Today we are going to design. I will hide these parts. Today we are going to design this drive. It's very simple. Going back to this part, which we called the ball. Now we want to design the pin which will be mounted there. Afterwards it will carry the bearing and the gears, these gears. This is the pin or the pivot, and today we are going to learn how to design this part. It's very simple. Again, I will start a new part. On the front I will open a new sketch. I will draw this profile. I will need a center line because this is revolve. This line is horizontal and this line is vertical. Okay, again, now we are going to add the dimensions. This is 16, this is 5, this is 12, this is 1, this is 5, and the whole part is 46. Now we are going to add the diameters. This is 16, this is 28, this is 20, and this is 16. This diameter, you may make this diameter, this line and this line coradial, but it's a note or advice. If you want to add a bearing there, again, I just wanted to show you how the mechanism works. This is the mechanism. I will take a section there. This is the mechanism. and this is bearing, and this is the gear which is carried on the bearing. If you wanted to add a bearing there, it's very good to have this diameter to be less than this diameter, even 0.1 millimeter. It will help when you try to add or insert this bearing. This will help to make the insertion easier. So again, it's very helpful in this design to add this clearance between these two lines. Let's say 0.1. It's very enough, and we can add equal there. Okay, this 0.1 millimeter will help you when you try to add the bearing. The bearing will go easily there, after which it will be interfered in this area. By the way, this 12, the dimension 12, is related to the thickness of this bearing. This is the bearing. Its thickness is 12 millimeter. Again, this is very simple notice, but it's important, especially if this line was longer, meaning that I will delete this. If this 5 was 50, it will be very important there to add this clearance. If this two lines are coradial, you will have to press the bearing from here to here, all over this long distance. But just this 0.1 millimeter will help you to insert the bearing easily all this distance, after which you will just press the bearing there. Again, I will make a revolve. Okay, I will add a chamfer there, just 1 millimeter. I will add cosmetic thread. The command cosmetic thread is not found there, so you can go to search, set the search to commands, and type cosmetic thread. Now you can drag and drop this command there. I made this before. This is the command. Again, this is the command. I want to add a cosmetic thread there, but firstly I will add a chamfer there. Again, cosmetic thread on this edge. The size is M20. Or what's this diameter? This diameter is 16. Okay, again I will add M16. Yes, up to next. Okay, now this part is have this cosmetic thread. Again, using the command hole wizard, I will add M10. The countersink will be 12. The position on this face and this point. Okay, you can save this on the desktop. I will call it any name. For you, if you are making the design for the first time, it's very important for you to give names for these parts like this. This is my parts. Again, you can find all these parts on GrabCAD and you can download it. and you will find that all these parts are free and open source. You can edit the dimensions and show the dimensions and the features. Again, we are going to design this part. Now we are designing this part. It's very important to know how to design or how to make this part, this hexagonal here. It's very simple. Again, how to make this. Firstly, I will draw a hexagon there. This line is vertical and this dimension is 24. It's very important to have a dimension which have a range. It's important to choose dimensions which have ranges. So I choose 24. I will make extruded cut, flip side to cut this part, this outside part, and you can choose through all. Okay. Now I made this, but how to make this part? Again, it's very simple. How to make this? Going to the front, I will make this rectangle and center line, and I will mirror this rectangle about this line. This angle is 30 and this line height, let's say 3, and I will have a center line there. Now I will make a revolved cut about this center line, and this will produce the shape, this shape. Okay. So now we made this bends. Again, how to assemble this part? Going back to the part of the previous video. In the previous video we made this part, and also we made this part. We made these two parts in the previous video. Now I will make an assembly for this, and I will mount the bearings, making assembly from this part, which is axis 6 gear shaft. Okay, sorry. Again, making assembly from this part, which is, yes, axis 6 right angle shaft. Okay, I will add these two bearings, a bearing there and a bearing there. You will find this bearing in the folder which will you download from GrabCAD, or in the first video I explained how to download bearings and to do how to prepare them for using. Now I have this bearing. I downloaded this bearing and I explained how to make this in the first video of this playlist on YouTube. I will drag and drop this part there. I will add mate between this and this, and between this and this. Okay, this is the first bearing. The second bearing is 30 mm, which bearing is 6006. This is the bearing. Okay. Again, I will add mate between this and this, and between this and this. Okay. Now this bearing is ready, or this assembly is ready for usage. I will save it Again, you can choose the name you prefer. Now, going back to the ball, from this part I will make a new assembly. From this part I will make assembly. Now I will drag and drop the previous assembly which I just made it. This is the assembly. How to drag and drop this assembly into this assembly? Just drag and drop from there, from the part name there to there. Okay. Now I will need to add mates between this and this, and between this and this. Okay. By the way, it's very important for you to study how to design these parts to fit like this. I didn't make it from the first time. I made many trials. By the way, this 1 millimeter also is important. This clearance is important there. I want the axial load to be carried on this bearing, but this bearing must have this freedom. It's wrong to make a zero there and zero there, a contact there and a contact there. No, there is a contact there, but here there is no contact. Again, this is the bearing. This is for carrying axial loads and radial loads, but this is just for radial loads. And also it's very important to have this clearance. It's not recommended, or you can say that it's bad or wrong to have this. Let's say I will edit this in a wrong way. Now I made the wrong design. This is wrong. This is wrong. Because maybe the contact will happen there, but there may be clearance. May a clearance happen there. So this design is wrong. Again, we must have this 1 millimeter clearance. It's very important. Okay. Again, I made or designed this part. I will add mates between this and this, and 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 between this and this. Okay. Of course, this is thread. This is a thread. This is threaded, and this also is threaded. So they will be mounted easily. And this hexagonal is used to tighten the thread. Now we are going to mount the bearings. This bearing is okay. I will take a copy. I am taking a copy by just clicking, pressing on Control and drag and drop the part. Again, this is one mate, this is the second mate, this is the third mate, and this is the fourth mate. Again, you can notice that all dimensions I have a wrong mate there. This is coincident. Again, sorry, this part has a wrong mate. This is the wrong mate. I will delete it. Again, I will add mate between this face and this face. Okay. Again, these dimensions are built on the dimensions of the bearing. The last thing for this mechanism is to prepare these bearings, these gears, sorry. How did you make this part? It's very simple. Again, I will make configuration just to in the first video I explained how to make this bearing, this gear. Now how to make this features. It's very simple. You have two methods to make this. The first method is to have a circle after circle, let's say 32, extruded cut, let's say 50. Afterwards I have a bigger circle, let's say 42, extruded by 17, and the third, let's say 44, extruded cut. Now I want to make the snap ring or the retaining ring groove. Now I will start with offset, let's say 3, and the depth of cut is 1. Now I made this features, but I don't prefer to make this. There is another method which is easier. I can open a sketch on the front and I can draw a sketch like this. Notice that I drew it outwards. If I draw it in this area, maybe I have problems with snaps. Now I will give sorry. Now I will add the relations. This point at the origin. This line is, let's say 3. This line, let's say 12. This line is 1. And this point on this line. Now I will add a center line there. Take care not to have problems with dimensions. Again, it's recommended to have a clearance there, but I will not make this again. I just make it for one time, just for explanation. But you can make this by yourself afterwards. This is the bearing, which is 12. Now I can make this 4. I think this is better. I can measure this distance. Okay, this is the best profile. Now I will make revolved cut. Okay, I think that this is a better method, but in the files which will you download from GrabCAD, you will just find this long pad method. Again, when you are making a design for the first time, you just have the concept. You don't concentrate on the method. You just concentrate on the concept. You just want to make this shape. In the second time, you have the opportunity to make a better design. Now I will add this part to this assembly. Again, I will take a copy from this. I will add mates. I always start with concentric mates. This face of bearing will be there. I will add another mate between these two gears, this last two gears, between the front of this gear and the front of this gear. I want them to be parallel. Okay. Why did you make this mate? To have this motion. Now, the last thing is to add the gear mate. It's very simple. I just want to remember the number of teeth of this gear. I think it is 24. 24, okay, and this is 52. Okay, I will add mate, mechanical mate gear between any circle or any cylindrical face from there to any cylindrical face from there. 24 and 52. Okay, you can examine the motion before you accept. Okay. Again, this is the motion now. Okay, the last thing is to add the assembly of these two plates. Also, I explained how to make this assembly in a previous video. Now I will add these mates. These are concentric and these are coincident. The last thing is to add the gear mates again I want to add gear mate. Go to mechanical mates, gear, any cylindrical face and any cylindrical face. The number of these is 52 and 128. Again, you can examine the motion. It's reversed, so I will choose reverse. Okay. Now, if you have interference between these teeth, you just go to mates and suppress this gear mate and move the gear until you find it's fine, and again unsuppress this mate. Now I want to examine the whole motion. This is the motion. The planetary gear is very beautiful mechanism. Again, going back to the main mechanism, this is the planetary gear mechanism. In the next video, I will explain, if Allah wishes, how to design the right angle drive. In the next video, I will explain how to design this drive. It's also very beautiful drive or mechanism, and very simple, but I think it will be explained in an easy way. And by the way, it have some tricks. You can say some tricks how to mesh these gears correctly. Most of people have problems with meshing these gears correctly to have the right clearance there. I don't want to say that it's complicated, but it has some tricks, and it's very simple, by the way. Again, this was a video of the planetary gear of the 6-axis planetary drive. In the next video, if Allah wishes, I will explain the 6-axis right angle drive. This is a very beautiful mechanism also. Thanks for watching, and wait the next video. Thanks. Welcome to Marzouk SolidWorks Tutorials and Designs. Today we are going to we will continue the explanation of this design. In the previous video, I explained the planetary gear drive there of the 6 axes. In this video, I will explain, if Allah wishes, the right angle drive. This is the mechanism of the 6 axes. First of all, I am trying to design this part. It's very simple part. How to design this? I will open a new part. On the right, I will design, or I will draw this I will trim these lines and I will make center lines from there to there and another center line from there to there. I will add equal there and equal there and equal between these two lines, and both of them are 8 millimeters. Again, I will add the next dimensions. This is 15, this is 6, this is 14, this is 1, this is from there to there is 29, and from there to there is 16. Now I am trying to add the diameters. The biggest diameter is 144, this is 100, this is 72, this is 64, this is 55, this is 48, and this is 30. And I will make a revolve about this center line to get this shape. By the way, you may have a problem asking why did you choose this dimensions. I may give you a simple advice how to learn to produce these dimensions. I produce these dimensions according to the design. This is the design. Now I have to add a bearing there. I go to this bearing and measure. This is 15. Okay. I go back and set this diameter or this depth to be 50. That's why you made this 15. This is 14. Again, going back to the design, and we'll find that this bearing, its width is 14 or 13. I will show you this 1 millimeter there. Again, this is 13, and I need this clearance. I need this clearance to make sure that the load is carried on this face, on just this face, not the boss. This is called in mechanical design anti-duplication. Anti-duplication. We don't need, or we don't like, or there are problems if you make a contact there and a contact there. So you must kill one of these two faces. Of course, you will kill this face, not this face, because I need this face to load the axial load of the bevel gear. So I chose this as this type of bearing can carry axial load. Again, I need also this 1 millimeter clearance to make sure that this race don't have any contact with this face. The race, the inner race of the bearing, this is the inner race. This race must have clearance with the body of the sleeve or this part. Afterwards, I may make another video about mounting the shafts. Mounting shafts is very important, and there are many problems happens when designers want to mount a shaft. So I will, if Allah wishes, I may make this video. I think it will be very good for designers. So I made this part. Going back to the assembly, I will show the hidden parts. Okay. Now I need to insert the new part. Now I want to insert this new part. Okay, this part. I will just add a whole wizard M8. On this face. This is my, again I wanted to ask about, or I wanted to make sure of dimensions again. Sorry, this is $40. Okay, and also we have this counter bore. Now I will make a circular pattern of these two features, the hole and the counter bore, about any of these cylinders. The number is 12. Okay. Now I made this part. I will insert this part into this assembly. Thanks. Okay. I will add mates, this cylinder with this cylinder, and this face with this face, and the last part. This is the last part. The front, sorry, or the right of this part with the right of the whole assembly, to make sure that this part don't rotate. Okay. Now I will need to insert the other assembly of this assembly. Going back to this assembly, I need to make a configuration now. I need to make a configuration. It's not the method to change this configuration. This is wrong. Now you are in the same configuration in the assembly. But how to make this? The right way to make this is to firstly make new configuration in the assembly. Let's call it number 2. In this configuration, I will change the configuration of shaft. So I have the first configuration of assembly, not of the part, have this part, and the second configuration of the assembly have this part. Now in the big assembly, or in the main assembly, now I will drag and drop this assembly. Press control and drag and drop this from here to here. Now for the second sub-assembly, I will change, this is the second sub-assembly, I will change the configuration of the sub-assembly, not of the part. So you have now So you have now this configuration of assembly and this configuration of assembly. Now I will add some mates, this with this and this with this. Okay. The most important thing in this video or in this tutorial is how to edit or how to prepare the bevel gear. The bevel gear. Going back to the main robot, how to add this gear. And I will explain this in the next video. Thanks for watching. Welcome to Marzouk's Robotics Tutorials and Designs. In the previous videos I explained how to make this sleeve and also how to make these shafts. I explained how to make this sleeve and how to make these shafts, but I preferred to make this tutorial just for these two gears, how to mount these two gears. It seems simple, but it has you can say a simple trick. Firstly, I explained before how to generate the gears, but no problem, I will explain it again. I opened an empty assembly file, going to library, toolbox, choose the standard, going to power transmission, gears and straight bevel gear or pinion, no problem. I will wait for a second. Okay, it's better to close other applications when you are now escape. I will close other parts because dealing with this library gears need need more RAM in your computer or PC or laptop. Okay, now this part is fixed in its place, but it is not related to these planes. So I firstly want to float this part. This part now can move, and again I will add mates to locate this part in the origin. Now I will add mates between plane 1 and the front, okay, plane 2 and the top, okay, plane 3 and the right. Okay, now I am sure that this part is in the origin. Okay, again I will edit toolbox component and I will change some data there. Module is 2, number of teeth 36, pinion number of teeth 36. By the way, this number is very important. If you change it this like this, it will change the angle. You can notice this. So it's very important. If you are trying to design the gear, you must know the number of pinion, and if you and vice versa. You must know the two numbers of pinion teeth and the pinion gear before starting design. Pressure angle 20, face width 20, hub diameter let's say 60. Mounting distance, okay. Nominal shaft let's say 10. This is the shaft, the nominal shaft. This is the nominal shaft, okay. Okay. Up till now there are no problem. Up till now there is no problem. The next step is to save this assembly as file. Save as not assembly but part or components. I will call this bevel gear module 2 number of teeth 36. Okay. Now you can forget this assembly, save the file because you may need it again. By the way, if you have problems with this part, you can't edit these dimensions. You must go back to the assembly file and generate another gear. Okay. The problem now is that you already have the gear, but when you try to make assembly of this gear, you don't know the distances between this faces and this face. It has many fractions. By the way, I may show you the problem firstly. Now I want to show you the problem. Now this is the assembly, and I will try to add this part or this gear to the assembly. Okay. I will add mates between this cylinder and this cylinder, between this cylinder and this cylinder. Okay. I will add mates between the front of this gear and this face parallel. Okay, and also the front of this gear and this face parallel. Okay, now we have this motion. If this shaft rotates, this gear will rotate with it, and also this. Okay, the problem now is at which distance we must put these gears. It's impossible to put this just like this by hand. Even if you make this in the assembly or in SolidWorks, you must manufacture this. You must produce this gear, so you must know the actual distance or the real distance to this face. Okay, going back to the concept of gears and bevel gears. Firstly, we have addendum circle and dedendum circle and mean circle. The mean circle is the circle on which the two gears will mesh there, and we know that this circle is the diameter of this circle equals the number of teeth multiplied by the module. Okay, firstly I want to get the end of this circle. Firstly I will start with the addendum circle. Where is the addendum circle? The addendum circle is this, but this is a small arc or a small segment of it. So I want to draw the whole circle. Going to sketch, I will open 3D sketch and I will choose this type of circles, perimeter circles, and I will choose any 3 points of these gears. Any 3 points of them will draw the circle. This is the addendum circle. This is the addendum circle. Okay. Going to the front now, I will draw a line from there to there to there. This line has 45 degrees because we know that the number of teeth are equal. This point will be coincident with this line. Okay. The height of this circle is not the important is not the important thing, but the important thing that the height of the circle of the addendum, which I know that this is 36. The radius of it is 36. Okay. At this intersection point will be the mean diameter. At this intersection point will be the mean diameter. Okay, starting from this point, going to this point, if these two lines are perpendicular, I made them perpendicular. Okay, and now I want to catch the point at which the two gears will mesh, or the common point of two gears. This is the line which will draw the contact surface between the two gears. Okay. The important thing now is when you calculate the distance from there to there, it may have problems. You may have problems with this value. It may contain fractions. So I need to make another correct number, let's say 40. Okay. And on this face, I will draw a big circle, let's say 200, and will extrude cut up to this point. Why did you make this? Just to make sure of the distance between this point and this face. Again, the problem occurs or happens because sometimes you don't know the real distance between this face and this face. Again, in SolidWorks you can find it in the generating gear, but again I explain this to just show the concept or the meaning of this number. Again, going back to the generating file, there is a number there. Which is this number. I made it quickly. This is mounting distance. I made this number quickly and made this number 50, more than 40. I will use 40, not 50, but just to show you what is the meaning of this mounting distance. This distance is the distance between this face and the common point between the two gears. And not in all cases this line will be 45. This case the angle is 45 just because we have two equal number of teeth. So now we have a clear gear like this. Again, just for explanation, I will draw a plane passing through this line and perpendicular to the front. Okay. Again, I will make a mirror about this plane for this body. Okay. Looking from there, this is the line on which the two gears will mesh, and this is the common point between the two gears. This is the common point between the two gears. What is the mounting distance? This is the mount from this point to this face, the back of the gear. By the way, we can solve this problem going to direct editing, move body. I will move this body without copy. I will rotate about this cylinder. Okay, no problem. Firstly, I can draw a line there. This is just for educational purpose. I will delete this afterwards. Okay, I will move this body. I will rotate without copy. I will rotate about this line. We have 36 teeth, so every teeth and cavity beside it have the angle of 10. So if I move this 10 degrees, sorry, 5 degrees, okay, oh yes, in this mirror I made merge. We don't need to merge. Okay, again I will move just this body, okay, this is the mesh. Again there was a problem happened when I made mirror. I checked this box merge solid, so it made the two gears as one body. When I tried to move or rotate this part, it rotates this part also. So I checked out this merge box, so I can move this part only. Again, also for educational purpose, I can draw a line like this and a center line like this and a center line like this, just to show you the planes on which, or the surfaces on which the two gears are meshing. Now I will make from surface, revolved surface, I will revolve this about this. This is one surface. Okay, again I will make a revolved surface. I will revolve this about, sorry, I will make a revolve about this line. Okay, now I can hide this body and this body. These two cones are the cones on which the contact happens. You can upgrade the concept of the mean diameter to the concept of the mean surface like this. On these two surfaces, the gears are meshing. Okay, I will delete all of this now. From there to there. Okay. And this also. Again, I will show this gear. Okay. This video may be somehow, I don't want to say difficult, but it's beautiful if you like the concept of the video. Now I have clear face here on which I can make coincident from here and coincident from here. Okay, again I need to add the mechanical mate gear between this face and this face, 1 to 1. Okay, I can examine this. Okay. Again, now I want to rotate this. Okay, I had because this is an educational project, I wanted to make another method of you can say of tightening or fixing this gear to this shaft. So I made another method. I made this hexagonal boss there, which is 40, and on this gears I made the pocket or the extruded cut, which also is 40. But now we have another concept. Again, this distance is, I think, 6. Here there is a very important note. Again, let's take a section. What is a note? Now I will remove this mate of parallel. I will freeze this. Why did you make this? Just to add a new relation between these two faces. Okay. Here there is a very important note. I made the contact on just this face, between this face and this face, but I killed this contact. This 1 millimeter difference or clearance is very important. This 1 millimeter is very important. You can't make this boss depth is 5. This boss again, you can, this line is 5 millimeter. Okay, for this pocket you can't make it also 5 millimeter. It must be more than 5. I made this 6 with the same concept. Now I can calculate the distance between this face and this face, and I will make a pocket for 30. Also, this distance must be 1 millimeter. Again, I will measure between this face and this face. This is 3 millimeter distance, so I will decrease this pocket by 2. Now, this distance also is 1. I need this 1 millimeter clearance and this 1 millimeter clearance. It's very important for me. When I add the bolt now, this bolt will make a compression between this face and this face. I just need these two faces, but there is no contact there and there is no contact there. And I choose these faces because it is the most or the biggest faces in diameter. So it's very, very important notes, and this is the same here, the same concept. This concept is called anti-duplication. the duplication is that to have something like this. Simply I will make a simple if you now trying to add a part there, it's very wrong to make the second part like this. This is very bad design. This is a very bad design. Okay, what is a good design? The good design is to add this clearance, let's say 0.5 millimeter. This is very important. This clearance is very important. Now I have the pressure or the bearing just between these two faces, these faces, but I don't have duplication. Okay. Again, going back to the design. Now, moving this gear will move the other gear, and moving these two mechanisms will move the outer ring, or you can say axis 6 of the robot. This project I think is very good project. I loved this project. Again, I will show now. I will show all this hidden parts. Okay. Now moving this. Moving this will move this plate, and this is axis 6. By the way, it's the longest axis drive coming from here through the planetary gear, through the right angle, through the belt, and through this gears here, and through this universal joint, and through this coupling, and this is the motor. This is the motor 6, sorry, axis 6 motor. If I move this now, if I move this shaft now, this will move axis 6. You can notice this. This is the longest drive in the whole design, but I think it's beautiful. It's very beautiful. By the way, this design is not copied from another design. The concept is taken from a famous robot. It's a KUKA robot, but they don't use these mechanisms. They use other high-end mechanisms. They use very expensive mechanisms, which is called harmonic drive. It may be complicated, but I need to make this project more simple. It's an educational project, but if you are working for a company like KUKA, you will have to make the real design or the complicated design. but now I am working on an educational project, so I am interested in making simple mechanisms just to be easy for educational purposes. I think this video was you can say complicated. You can see the video more than one time, and it's very important to practice. It's very important to practice this videos. And if you have problems with generating the gears or this problems, you can go to the files. You can download it from GrabCAD, from my account on GrabCAD, and all these files are free. It means that if you open any one of this, you will be able to edit it. If you open something like this, you can edit all the sketches and the features, something like this. You can edit these features, so you can go and take the gears. This gear is found in the folder, and you can edit the dimensions. By the way, it's very important advice here is that you may say that you choose I choose the dimensions. You don't have this opportunity. No, I can tell you that you have this opportunity. You can decide to change the size of this shaft. Let's say you can decide that this diameter will be, this is 26, I will make it 32. Okay, and you can regenerate all the dimensions, and regenerate all the bearings there, and regenerate all the dimensions of the gear. But I advise you to make this in the next or in the second trial, not in the first trial. Firstly, try to make the same dimensions as I made, but I advise you can take all this design and you can say that I will make the first dimension in the project is this is 200 millimeter. You can say that I will start the project with 300, and you can regenerate all the project. You can regenerate all the project. If you make this 200 300, you will regenerate this gear. This gear is 24 teeth, module 1. You can say that this will be 30 teeth, module 1.5. And you can regenerate all the design, because this gear is like this. This bearing is 30 millimeter in the inner diameter. In your design, it will be 40. So you will be forced to change all the design. Again, you may want to make your own design, and it is your right. How to make this? Just change one diameter and try to regenerate all the design. If you made this, you will need to regenerate all the dimensions like this. You will need to regenerate everything in the design. You will regenerate everything. So it's a very important advice, but I advise you also to make this after the first design. Firstly, I advise you to design with the same dimensions. Afterwards, I advise you to make another design with other dimensions. Thanks for watching, and wait the next videos. Thank you. Welcome to Marzouk SolidWorks Tutorials and Designs. Today we will continue the design of this robot. In the previous videos we explained axis 6 and the movable parts of axis 5. We completed all these parts and assemblies. Today we want to continue to design 3 parts, this part and these 2 parts. This part is a frictional plate of axis 6. Today we will learn how to design such a part. It's a very simple part. I will start a new sketch, a new part and a new sketch on the right. I will draw a circle with the diameter 160 and extrude with 12 millimeters mid plane. Okay. I will add chamfer there just by 1 millimeter. On this face, I will draw a slot like this. I will edit the dimensions. This is 15, this is 20, and I will make a center line from there to there, and this center line is vertical, and I will make another center line from there to there, and this center line is 2 millimeters, and I will extrude cut through all with this sketch, and I will make a fillet there and there. Okay, may I change this value to 8 or 6? Okay, now I will make circular pattern of these 2 features, this cut and this fillet, about this circle with 12 instances. Okay, again on this face I will make line between this point and this midpoint. Again I will make ellipse, slot with this shape. I will add perpendicular between this line and this line, and I will edit the dimensions. This will be 5 and this will be 24. The distance, I will make a distance between this point and this point, and this distance is 11. I will make extruded cut by 1 millimeter and taper with 45 degrees. This is the extruded cut. Again I will make a mirror about the front plane or the right plane of this feature. Now I will make a circular pattern of this mirror feature about this cylinder. Okay, I will save this. Let's call it axis 6 plate or friction plate. Again we will continue with this part. On this face I will draw a hexagon, 6 segments and circumscribed circle like this. This line will be vertical and this circle will be 76, and I will exit this sketch. Again on this face I will open a new sketch and I will make a circle and another 3 circles. All these circles are equal, and this circle here is 16, and again a circle here, and this circle are equal. So I have 2 phi 16 and 4 phi 12, and I will extrude cut through all, and I will hide this sketch. Now on this face I will make a circle with the diameter 20, and I will make a circular pattern about this point from this circle. Number of instances are 6, and I will make extruded cut with 4 again. On this face I will make 2 circles, 30 and another circle which is equal, and I will make extruded cut by 4. This extruded cut is just by 2. On this face I will convert this face and also will convert this face, and I will make 2 circles, 11 and this is 11, and this circle and this circle are equal. From this sketch I will make extrude by 4, but I will not merge the results. So I have separate 2 washers. These are washers, but I preferred to draw them here just for simplification. Now this part is completed. The function of this part is, by the way, there are circles there. These circles are made just for lubrication. I will explain the function of these circles, but I will draw them firstly. Center line by 20 and a circle by 6, and extruded cut through all, and circular pattern of this circle about this cylinder. Okay. Now this part is ready to be inserted into the assembly. This is the assembly. What's the function of this part? This is the assembly. This part is a frictional plate. I will add a mate between this face and this face, and between this cylinder and this cylinder, and between this cylinder and this cylinder. Of course there will be bolts there. Now I will show these hidden parts. Now I will take a section just to show the function of this plate. This plate is a frictional plate. I think the distance, I will measure the distance between this face and this face. It's 11. So I think this part will need to What is the problem there? Again, I will delete this mate just to free this plate. Again, I will add a mate between this face and this face. Okay, so I think this plate is 11, not 12. Okay, and I will decrease this depth. I will make it just 1 millimeter. Okay. Now it works. What is the function now? The function for this plate is that it is a frictional plate, and I made this cut and this cut just to decrease the friction between the plates. And again, in the real design, this mechanism is not like this mechanism. This mechanism is not like the real one. This is made just for simplification. When you try to assemble this part or this assembly, this part will be the first one, the second one will be this, the third one will be this, and the fourth one will be this. Again, if you want to understand how this assembly will be made, I will make an exploded view. This is the last one to be added. This is the second. When you try to assemble this part or this assembly, this part will be inserted firstly, and of course with its gear. Afterwards, this part again. Afterwards, this part will be fixed with this part. Afterwards, this part will be fixed with this part. So you have this part and this part are fixed together, and this part and this part are fixed together. Again, this part and this part are fixed together, and you can see this idea. Again, these two parts, this part are fixed to this part, and these parts are also fixed together. But of course, this will not be able to be assembled as one piece or as one sub-assembly. Of course, this part will be inserted firstly. Afterwards, this plate will be assembled to the ball. Afterwards, the outer plate will be fixed to the ring. So this is this part. The second part, I hide the parts which we finished it, just for simplification. The next part is this part. It's a very simple part. I will open a new part. On the right, I will draw a circle 30 diameter and a circle 100 diameter, and will extrude this by 20. On the front, I will draw a center line at the height of 40. On this center line, I will change this to a line, and I will make another center line like this. I have two diameters, 15 and 10, and this line is 9, and I will make a revolved cut about this center line. Now I have this cut. Afterwards, I will make a circular pattern of this feature about this cylinder by the number of 12. Okay, this is a very simple part. I will save it with any name. Okay, the last part is this one, and also this is very simple. Again, I will open a new part. On the right, I will make these two center lines, and I will draw this contour. Now I will try to add dimensions. This diameter is 32, this diameter is 72, this diameter is 90, this diameter is 144, this diameter is 19. By the way, I will have to make two center lines there and make them equal. Again, I will make two center lines there and make them equal, or I can just add parallel between these two lines and also parallel between these two lines, just to have 45 degrees. Again, this line is 5, this line is 8, this line is 8, this line is 28, and this line is 25. I think we have just this diameter. This diameter is 16. Okay, this diameter is 16. Okay, and I will make a revolve about this center line. Okay. Again, and with the same method, on the front, on the right, I will make a center line with 54, and on this center line I will make this counter bore. This line is horizontal, and I will need a center line there. This circle is 15, this circle is 10, and this line is 9. I will make a revolved cut about this center line, and will repeat circular pattern of this about this with the number of 12. Okay. and I will save this with any name. Okay. Now we have designed all these parts. I will hide this part and I will hide this part. Just for simplification, these parts are not the most important parts in design. We have more complicated parts like this, so I want to go to them quickly. I will explain how to design this part in the next tutorial, if Allah wishes. And also we have this pulleys. Also it's very simple. Maybe I will draw this now. I have 4 configurations of this pulley. It's very simple. Now how did you make this configuration? It's a very simple part. This is the first wall. I opened a part and make a new sketch on the right, and I make this profile, and I will make mirror of this about this. May I need to make this like this, and I will have a center line there. This line is 2 millimeters and the whole width is 30. The outer diameter, I think it is 60. This line I think is 4, and this is the inner diameter. I will make this to be 10 as initial value. Again I will revise 32, okay, 98 and 100. Okay, this is 104 and this is 98, and I will make a revolve about this line. Okay, the second thing to be designed on the front, I will design this simple again. I will need the dimensions. This is 6 and this is 4. Okay, 6 and 4 and 48. Again, this is 48. This is 6 and this is 4, and this line and this point are coincident. This line is the extension, or the origin is on the extension of this line, and I will make mid-plane extruded cut by the value of 26 like this. This is the first cut. The number of teeth is 24. Okay, now I will make a circular pattern of this cut about this. The number is 24. Again, you need to make some modification. I mean that you may modify this part and change some values just for practice. Now I will add a fillet of 1 millimeter on this line and all these lines. It's a very important and useful method of adding fillets. Not all this, okay, sorry, clear again, of this line and Okay, if there is a problem now, I can cancel this and roll back the pattern, and now I can add a fillet on this part, on this line, with 1 millimeter, and this, and this, and this. Okay, I think 1 millimeter is very big. I will make it 0.3 or 0.25. Okay, now in the circular pattern, I will add also the feature of the fillet. Now it will be repeated or patterned with the circular pattern. Again, this is the first part. Now I have 3 configurations. In the first configuration, this value is 52. In the second configuration, this value is 72. In the third configuration, this value is 14. Okay. Now I will make this to be 14 in the first configuration. Again, this 14 I will make configure by 2 and make this value 52 and this value 72. Okay, now I have 3 configurations of 4. I need 4 configurations. Now I made 3. This is the whole of 52. This is the whole of 72, and this is the whole of 14. In this configuration, I will need to add this cut 28 by 20. On this configuration, I will add this cut 28 by 20, and this hole or this counterbore will be just seen in this configuration. Again, if you want to do the second configuration, you will not find this value. Again, the fourth configuration is this value in the fourth configuration is 18. Okay, I will make this again this 14. Configure dimensions. The last configurations will be 18, and in the last configuration, number 4, I will suppress. Sorry. In the last configuration, I will suppress this hole, and I will add this cut. It's also a very simple design. Again, going back, I am now in the configuration number 4. On the right, I will draw. Again, if you have some part which has complicated geometry like this, it's preferable to draw your contour outside, and after which you can pull it inside the design. Now I will say that these 4 lines are equal and the value is just 1. Again, this value, let's say that this is 5, and this value, let's say that this is 18, just to be sure that when I will move this, it will move as one piece. Now again, I will delete this value and drag and drop this line to come there. Sorry, I think the value is between this part, this line, and this line. Okay, now I will add the center line, and I will add the diameters. Let's say this is 30, this is 50, this is 60. Again, I just will make sure of the values. This diameter is 30, okay, and this is 60, okay. this is 30, this is 60, and this is 68, this is 60. Okay, and after which I will make a revolved cut. Okay, just like this. Again, I just will make sure of some dimensions. This is 6 and this is 7. Okay, again this is 6 and this is 7. This hole will carry the bearing. We will watch timing belt. We will watch the function of this part afterwards, but I just draw this to simplify the project. Again, if you want to know the function of these 4 wheels, it will appear in this subassembly. Now these are the last pulley which I drawn, and this carries this bearing. There is no friction there, and this is one of the belts also. This moves, this hero shaft moves with this shafts and takes the motion from this motor. It's carried in maybe a strange way. This timing belt and this gear are carried on these 2 bearings, which is carried on this green sleeve. This green sleeve moves like this. It's another axis. This is axis 5, and this sleeve is carried on the outside part. Again, if you want to the main assembly or the biggest assembly, I just want to make you see how this green sleeve is carried. This green sleeve is carried on this bearing, which is carried on this part, and from the other side is carried on this part, on this hero. By the way, we will, if Allah wishes, we will explain all these parts one by one. But now I just want to simplify the project. Now we drawn this pulley and this pulley, or this timing. This timing here. I think the next video I will draw this yellow part, or maybe the belt. The belt also is very beautiful part, and also it's very simple. It seems to be complicated, but it's very simple. Okay, up till now you can say that we finished all the movable 6 axes and 5 axes. Also 5 axes are finished now. I want you just to watch the motion of 5 axes. I will just free the 5 axes. This is axis 5 fixation. I will suppress this fixation. By the way, some problems like this happens, but if you try just to open this part and rebuild it and close it, you will find that the problems will be solved. Or you may need to suppress and unsuppress the mates, but I'm sure that there are no problems in this assembly. But this happens. I'm sure that there are no problems in this assembly, but this happens with SolidWorks. Okay, no problem. Okay, now I want you to watch the motion of axis 5. The motion of axis 5 comes from this motor. This motor moves this shaft, and this shaft moves this shaft, and this gear moves this gear. This gear moves this green one, this green sleeve, and this green sleeve moves this pulley, this timing pulley, and this timing pulley moves this belt, and this belt moves this pole. Again, I will move this green sleeve now, and this moves axis 5. Again, this pulley is connected with this belt with this pulley, which is connected through this green sleeve to this gear, and this gear is connected to this gear and through this universal joint till this shaft of motor. When I move this now, this gear moves this one, and this one moves this green one, and this green moves this another gear, and this gear moves this belt till this mechanism. Again, I'm sure that there are no problems in this mate, just maybe the suppressing of this part. Again, I will unsuppress all these. part. Again, this is the whole assembly working now with the all mates working. Again, I will make a rebuild, but this problem happens. Some problems happens in SolidWorks when you suppress some parts, but it's all about, you can say, experience. So if you look there, you will find that I preferred sub-assemblies. I don't have many or lots of parts there. I prefer sub-assemblies. This is one. This is sub-assembly. So when I want to edit something, I just go to the sub-assembly of it. But it's not the right way to make all the assembly in one file. This is the second sub-assembly. Also, if I found a problem there, I will just go and solve the problem in this simple sub-assembly. But this ability is related to experience, but it's very simple, by the way. And this is one assembly. In this assembly, I have smaller sub-assemblies like this. This is also a sub-assembly, and also this is a sub-assembly. So I prefer to make, or to you can say, organize my files, not just adding files on files. Again, I just wanted to make sure that this shaft works. Again, I will move this. Again, I will move this. Okay, it seems that there is a problem there between these two parts. These two parts must be linked together. Again, I will search for any mate which is suppressed. Maybe I suppressed a mate there. Okay, what's the problem now? Okay, going back to this sub-assembly. This sub-assembly must have a relation with this. Okay, I will add this relation between this face and the front. Okay, parallel. I will make this parallel. Okay. Now this just have this degree of freedom. Okay, again, going back to the sub-assembly. Okay, this is one. Again, I will delete this and will unsuppress this. I think this is the problem was there with this angle. Okay, going back. I think this will solve the problem. Okay, it solves the problem again. It's all about being patient. Being patient. It's not you must not get nervous or angry from these problems. You must be patient, and you must learn yourself how to deal with these problems. It may cause angry, but you must deal with this. This is axis 4. Okay, so I think now we finished. I think we finished a big task. We finished these plates there, this movable plate in axis 6, and now we finished also axis 5. I will suppress it. The next step is to draw even maybe this yellow part or the belt. With the next video, okay, thanks for watching, and wait the next video soon if Allah wishes. Thanks. Welcome to mmswtd tutorials and designs. Today we are working on this project. This is video number 11 or 12, and today we are working with axis 4. This is axis 4. Again, you can understand this motion. This gear moves these two gears, and these two gears move this gear. This is like a planetary gear, and all of them move this part. And today we are going to design this part. It seems to be complicated, but we will try to make it in a simple way. How could we design such a part? We will open a new part. On the front I will open a new sketch, and I will draw this contour. I will add some dimensions. This is 2, this is 14, this is 16, this is 18, and this line and this line are equal. This is 20, this line and this line are collinear, and this diameter is 264 and this line is 70. Now all this sketch is fully defined. Now I will make a revolve. Okay, and I will save this part as Y part, because its shape is like the letter Y. Okay, the second step, on the top I will draw this sketch. I will make this a center line, and I will make a mirror of all of this about this line, and I will add some dimensions. The distance between there and there is 80. The distance between this and this is 40. This arc is 80, and this arc and this arc are equal. The distance between there and there is 220. This distance is 232, and this is 360, and I will make extrude mid-plane with the value of 180. This is the second feature. Now I need to make foreground fillet there. I can make foreground fillet between these three faces, or you can draw a circle there and make this circle tangent to this line, and make this profile and trim this point and make equal between these two lines. By the way, I can add another line. I can make equal between this and this, and add any dimension there, let's say 10, and use this as extruded cut through all. This helps that you made the fillet of two faces in one step. The second thing is, on the top I will draw a rectangle there and a center line there, and I will make mirror of this, and I will make a center line there. I will make this diameter to be 128 and this line to be 10, and I will make a revolve about this center line to have this two bosses. After which I will make on the front, I will make a center line there, and I will draw. By the way, it will be better if I draw this there. I will make this profile, I will add some relations. This line is vertical, this point is on this arc. I will add some dimensions. This diameter is 150, this diameter is 120. These three lines and this line are all equal, and all of them are 1 millimeter. This line is 5 millimeter. This line is 18, and this line is 17. About the diameter, this diameter is 200, this is 72, this is 85, this is 95. Okay, I think there is a relation, one missed relation there. I think there is a line which need to be vertical or horizontal. Yes. This is the line. How could you discover the problem? Just drag and drop any blue point. This will make you know where is the problem. Now I will use this profile to make revolved cut. Okay, like this. Now I made this cut. By the way, this will need a 20 millimeter chamfer, and this will need 2 millimeter chamfer. This will need 20 millimeter fillet, and this also will need 20 millimeter fillet. This also will need 20 millimeter fillet. This will need 5 millimeter fillet, and this also, and this also. These fillets help the casting. This part will be made or manufactured by casting, so fillets are very important for casting. Again, now I need to make this hollow, this part hollow. How could you do this? Going back to this part, on the top I will draw this profile. I will make this line horizontal and this point tangent. By the way, don't try to make this by mirror, because there are two different arcs there. This arc will equal this arc, and all of them are 40, but this arc are 20 and this arc is 80. This is the difference, so I didn't make them using mirror. Now I will add some relations. This point and this point are vertical. The distance between this line and this line is 12. This line is 36. I will make a center line there and another center line there, and I will make this center line and this center line equal. I try to use the least number of dimensions, so I try to make all my work with relations. I don't prefer dimensions, but I prefer relations. As you can try to use relations, not dimensions. This value is 14 from here, from here to here is 14, and this point is on this line. Now this profile is fully defined. I will use it to make mid-plane cut with the value of 140. Now let's take a look. Now we hollowed this part. Again on the top I will make two rectangles. A rectangle and a mirror. Now I will put this point on this line, and I will put this point on this line, and I will make a distance there, let's say 20, like this, and I will make a center like this and use this center to make revolved cut. This revolved cut, again, this revolved cut made this. Again, just to watch. Why did you put this value to be 20? Again, if you remembered, the whole thickness of the part was 180 and the thickness of the cut was 140, so the thickness of the wall is 20. Again, the thickness of this wall is 20, so I used this value to be 20 here. Again, I will make a circle there with 100 millimeter, and will extrude cut, let's say 30 millimeter, to open this part. On the other side I will make 90, like this. Again, going back, this is 100, this is 90, sorry, and this is 100, sorry. Again, I will change the values. This is 90 and this is 100. Now I want to make this holes, this pivot holes on this face. I will make a center line there and a center line there, and I will make a mirror from this center line, about this center line, and this distance is 252. I will have two circles, 16 there and also 16 there. The distance between this line and this circle is 173, and the distance between this line and this circle is 1 4 1. I will use these circles to make through all holes like this. Now on this face I will make 32 circle and also a 32 circle, and I will cut with 5 millimeters, and I will add 2 chamfers by 2 millimeters on this edge and on this edge. Okay, and I will mirror these two features about the top plane of this feature and this feature like this. Use geometry pattern if there are problems. I will save this work. The next step is to make or to split this part into 2 parts, or firstly we may make these holes. Again, on this face I will draw a polygon with 16 segment and circumscribed circle like this. This circle diameter is 280, and this point and this point are vertical. This is now a fully defined sketch. I will exit this sketch, and again I will draw three circles there. All these circles are equal, and n of them is 10 millimeters. I will make 2 center lines like this. I will mirror these center lines or these circles about these center lines, and I will make holes of 20 millimeters like this. Again, on the same face I will make a circle there, and I will make a circular pattern about this point of this circle. Okay, and I will make extruded cut by 8 millimeters like this. Of course there are many methods, but this is an educational project, so I try to use different methods. Of course it was a very good idea to make a circular pattern. You have this freedom to make the part with the method which you prefer. Now I want to split this part into a part and caps. I will make a line there and a center line there, and I will mirror this line about this line. I will make this distance to be 20. Now I will add this point. I will add a coincident relation there and a coincident relation there. Never let the sketch underdefined. Always try to make your sketch fully defined. Now I will save this work, and going to direct editing and split, I will use this sketch to cut the part into 3 parts. I will auto assign. I will save the 3 parts, and don't check this consume cut buttons. Never check this button. Now the part will be split into 3 parts. This is one. This is one. I will isolate this. This is one, and this is the other 2. Now I want to make these holes. This is M6 holes. I will go to features and hole wizard and will choose straight tab. I will choose den and the size is M6. Okay, and the countersink is 7. I will use this feature to be applied to just this body, not the whole part. Again, on the position, I will choose this face and I will add any point there. Okay, and I will exit this part, this feature. I will hide this part. Going back to the solid bodies folder. I will call this or rename this as cap 2 and I will rename this as cap 1 and I will rename this as main body. Now I will hide these two caps. Again, going back to this feature, I think I chose the right face. There is a very good method to choose faces. Just right click and choose select other, and this will help you choose other faces. Now I will make a sketch. This is 80. These two lines are equal. This angle is 60. By the way, I can delete this angle and use other method. I will make all these lines equal. Okay, and I will add other 3 equal lines. This will make the sketch to be fully defined. Okay, I will put this point there and put other points, 1 there and 1 there and 1 there. Again, I need other 3 center lines and also 3 center lines there. All of them are equal and this line is 60. Now all of them are fully defined. Again, I will add 3 points there and 3 points there. Now I will make a center line there and a center line there, and I will make 2 center lines equal, and this distance is 10, and this point are horizontal with this point. Okay, and I will add 2 points, 1 there and 1 there. Okay, now I have this pattern of holes. Now I will make mirror of about the front of this feature, and this will appear there. Okay, now I will show these bodies and I will show hidden lines on this face. I will make a new sketch and I will add circles there. Don't try to make small circles, make such big circles. like this. You don't need to make small circles. You will control the size of the circles with the dimensions. This relation is wrong. I will add this here. Now choose all these circles and add equal, and any of them are 7 mm. And use these circles to make extruded cut through all, but choose the cut to be applied to just the caps, cap 2 and cap 1. These holes will never drill through the main body. Okay. Again, you can see the result. This is the main body. There are no holes there, but the holes just affected the caps. Again, on this face, I will make the same idea. I will make all these circles equal, and any of them is 12, and I will extrude it cut with thickness of 10. This you can consider this as a counter bore. Again, I will make mirror about the front of this feature. Okay. What's the problem with this mirror? Try to use geometry pattern, or you can choose this body to be affected without geometry. Okay. Again, I will use geometry pattern. Okay. Geometry pattern is very helpful. Okay. If there is a problem, I will delete this mirror and I will use the same sketch. Use the same sketch to make extruded cut, starting from this surface and with the depth of 10 in the other side. Okay, affecting this body. Okay. This is another method. I use start and end conditions. Okay. So now you can notice that this is a simple design. It's not a very complicated design. Again, I will add these features as the main body or the main features. Okay, just for organizing the file, I will add these holes to be, I will rename them as, you can say, shell. They are similar to shell. I will call this as pivot. These holes will be used for pivots. These holes, all of them are related to, you can call them or rename them as pattern 1. Let's say pattern 1. These two features are about splitting. This M6 and the mirror and the cuts and these 3 cuts, all of them are, you can rename this folder as cap threads. Okay, I think this is an organized part. Going back to, this is the main part. I think it is the same. We can check this by mass. This is 7917. Going back, what is this mass? This is, oh, there is, I think there is a different, or a difference happens in fillets. Most the difference between 2 parts are caused from, or the cause of them are fillets. Okay, but I think this is the same design. Okay, now you can understand that this face will carry a bearing. Okay, going back to the function of this part. This is the part. These holes are made for pivots, and these holes are made for this bolts. Of course, there is a cap there which closes this face. These 2 parts are fixed together. By the way, this is the only hexagonal head threads in the whole design. Why did you use this hexagonal and you didn't use Allen bolts or socket head? Because the Allen key will not be able to enter there. The Allen key will not be able to enter there, so I used these bolts as hexagonal bolts, normal hexagonal bolts, but all the other bolts in the design are Allen bolts like this. Of course, there will be a snap ring there, but I didn't put it in the design. You have to add these details. Again, this is axis 4, this is axis 4, and this is its motion. And if Allah wishes, I will continue to explain the whole design. Okay. Now I finished this part and I will hide it. In the next tutorial, I will explain how to design this belt. It's a very simple also, and it have some tricks. It's very simple, but it have some tricks, or one trick. It's maybe considered as one trick. And by the way, it's configured. Have 2 sides like this. Okay. So with the next video, and I hope this video helps. What's the problem? This is usual problems. What is the problem? There are no problems. Okay. Okay. Now I will end the tutorial and I will look for the problem. I think, or I am sure that there is no problem in this design, but it's just something is related to rebuilding in SolidWorks. Oh my god, I just moved this part and the problem was solved. So it needs some experience of working with SolidWorks. It is just a practice. You need practice. You need practice. If you practice a lot with SolidWorks, you will get used to these problems and its solution. I will hide these balls such to make the design lighter. And again, I has an advice. All the time, try to make your design as sub-assemblies. This means that I made all this parts in one assembly. So if a problem happened, I go to this sub-assembly and solve the problem in this simple sub-assembly. But don't try to make all the assembly in one file. It's very complicated and very hard, even for your laptop or your PC. Again, thanks for watching and wait the next video. Thank you. Welcome to SolidWorks Tutorials and Designs. We are now working on this project. In this video I will explain how to design this build. It seems to be complicated, but it's very simple. I will open a new sketch. On the top I will draw these two center lines. I will make them equal and I will make arc between these two lines and I will add tangency there, and this line or this arc will be 20 millimeters in radius, and I will make offset of 4 and bi-directional of this line, offset by 2, and I will use cap ends with lines, and I will make this line base geometry. It means that this will be a center line. Okay. This is the first sketch. I will extrude this with an offset 50 millimeters, and afterwards I will make a mid plane extrude with the thickness of 26. Okay. This is the first feature. The second feature on the right, I will make this center line with length of 146. On this center line I will make an arc like this, these 2 points are vertical, these 2 points are horizontal, and I will make a center line from the midpoint of this line to this point, and this line is horizontal. Now this sketch is fully defined, and I will make offset by 2 cap ends with lines. Okay, this is the second sketch, and also I will make extrude by 26 and mid plane. Okay, the third is on the front. I will make this center line, the dimension is 193, and I will make arc like this. These 2 points are horizontal, these 2 points are vertical, and I will make a center line from there to there, and this center line is horizontal. Again I will make offset by 2 of this line, and will cap ends with lines. Okay, and I will make extrude by 26 and mid plane like this. Okay, now I will make loft between this face and this face. This point will be with this point like this, and start and end conditions will be normal to profile and normal to profile like this. Okay, the same method, I press the enter in the keyboard, and this point will be, I don't choose the point, but I choose I click near the point like this, and also start and end conditions are normal. Now I will make mirror about the top of this body. Okay, and will merge ends. Okay, now for this dimension, right click and configure dimension. In the second build, this value will be 161. Okay, now I has 2 configurations like this. And this is the same build. I may calculate the mass. This is 85. Okay, and this is 85. This is the same design. Okay, 8544, and this is 8544. Okay, by the way, the files which you downloaded from GrabCAD, you will find some complicated design there. There is difference between the first design and the second design. The first design is conceptual design. I mean that when I try to design this build for the first time, it may take more time or more features, but after the first time, you can find better method for designing the part. But I think this method is I don't want to say the optimum method. I think it's very easy. By the way, how can you say that this method is easy? It's related to the minimum number of dimensions which you use, the minimum number of sketches, the minimum number of features. The simplest design is the best. The simplest design may be considered as the best design. And these 2 builds are used there. This is for axis 6 and this is for axis 5. Now I will hide these two builds. These parts are very simple. This is a very simple part, just one revolution. Very simple part. I think it doesn't need to be explained. And also this part, this is also a very simple part. Very simple. This is one revolution about this line, and also this chamfer may be added with the first sketch, like there. You can add the chamfer there. So I think these parts also could be hidden. In the next videos, we will start to deal with axis 3. This is axis 3. Now I can suppress this. Okay, and now I will 3 axis 3. Now I can move axis 3. Now if I move this shaft, axis 3 will move. And if Allah wishes, I will continue to explain how to design all these parts and mechanisms. By the way, there are many mechanisms there which are related to axis 6, 5 and 4, but the main parts of axis 4 are completed. I think there is other part from axis 4. I think this is axis 4 collar also, and also this is a very simple part. This is its dimensions. We have designed many parts like this. It's just a very simple revolution like this, and also the same method of adding tabs and holes. This is used. I wanted to show you how these parts are used. This part, I mean this part, and also this gear is very simple. And in video 1, you can go back to video 1 and or I think video number 2, and you will find how to design this bearing. This is an internal gear. The module is 2 and the number of teeth is 108, and this is 236 circle with extrude cut with 10. I explained the same technique before with axis number 6, the same technique, and here you will find how these parts are assembled together, and the friction plate will be there. You can see Now I will show this part again just to explain how this mechanism works. This is the mechanism. This is the mechanism. This is the frictional plate, and this is axis 4, which moves around this plate. I think this bolt will need to go down there. Okay, no problem. This yellow shaft is the shaft of axis number 6. This moves this belt pulley, and this belt moves this right angle drive, and we explained this before. It's a right angle drive, and this green sleeve is axis 5. This sleeve moves this belt pulley, and this moves axis 5. Okay, again, I think we don't need to explain how to design this part. It's very simple. And the dimensions, I will show the dimensions for you if you wanted to redesign the part. Now you can take a snapshot of this if you wanted to redesign this part. It's very simple. And again, this is the circle or the base circle or the base polygon for the holes, and this is the hole. These are 12 holes, M8 holes, and this 4 holes are for guiding pins. Okay. Again, in the next video, we will start, if Allah wishes, we will start working with axis 3. I just try to make the file light for my laptop. This is axis 3. And we will discuss how to design all these parts if Allah wishes. Thanks for watching, and wait the next video. Thank you. Welcome to Marzouk SolidWorks Tutorials and Designs. We are now working on this design. This is a complete robotic arm, and today we are going to design this part. It's a very simple part, and today we are going to learn how to design this. On the front, I will open a new sketch and I will draw these 2 center lines, and I will draw this profile. and I will add some dimensions. This is 16, this is 8, this is 14, and this is 28, and I can add any two center lines there and make them equal. This is just for the angle 135. I prefer putting relations more than dimensions. Now I will add some diameters. This diameter is 72, this diameter is 104, this diameter is 204, and this diameter is, let's say, 'm not sure about these two diameters. I will check them. This outer diameter is okay. This is 220. Now this profile is fully defined. This is the profile. Now I will make revolve about this center line. Okay. Now I will add a chamfer by 1 mm on this face. And on this face I will draw this slot. The dimensions are 20 and 20. This point is vertically over this point, and the distance between this line and this circle is again I will add a center line from here to here, and this line is 2 mm or 3, and I will make through all cut. Now I will add fillet there and there, and I will make a circular pattern of these two features about this circle. You can say 12 or 16. I think 12 is good. Okay. Again I will make sure about this pattern. This pattern is 16. Okay, again this pattern is 16. Again on the same face I will make a center line from there to there, and I will make another slot like this, or I can make a circle like this. The diameter is 36, and this line, these two lines are collinear. The distance between, I will make a line from this point to this point, and this line is this line is 15, and I will make extruded cut by just 1 mm and draft angle with 45 degrees. this is the cut. Again I will make mirror about. Firstly I need a plane to make a mirror about. I will make plane. You just need to choose these two faces, this face and this face, and SolidWorks will make a medium plane like this between the two faces. Now I will make mirror about this plane of this feature, okay, and I will make a circular pattern of this mirror feature about this circle, and the number is 16 also, okay. I will save this file, let's say disk number 4. This disk is responsible for axis 4. In this design there are these holes. These are made for oil. It's very simple, and I think you don't need to model this. Again, going to this phase, I will make a center line with 80, and I will make a circle with 18, and I will make through hole like this, and I will make a circular pattern of this hole about this circle. The number of holes are 16, and I will skip some instances. I will skip these 3 holes and also these 3 holes, okay. In the other phase I will make a slot from this type, starting from here, ending here, and this value is 40. And I will make center line here, horizontal, and I will make mirror of this about this, and I will make extruded cut of 3 millimeters. I think now the part is complete. This is the part, and this is the original one. It's a very simple design. In the file which you will download from GrabCAD, you will find it's very complicated, or in the first time you model a part, you don't have a full view of the part, so you may make some complicated steps. If you look at the file in GrabCAD, you will find that it's somehow strange. Started like this, flat disk, after which I made some, you can say, some complicated steps, but this is because I wasn't able to imagine the file before I start to design it. But in the second time, this design, or the first time to design the part, this is called conceptual design. You don't have a full imagination about the part, but in the second time you have the full imagination. You can look at the part from here and imagine that this will be one profile, and you can imagine the simplest way to design it like this. Now you can imagine this, and it looks to be simple, but in the first time you design a part, you have the right to make some complicated steps. So many times I design one part in 2 steps or in 2 parts. I design it firstly, afterwards I make another design which is simple and clear. Again, in the main assembly, this is the part which is responsible for axis 4 motion. This is the friction plate of axis 4, and it looks to be simple to imagine how this works. This part is assembled to this part, and axis 4 rotates about this disk. This is a frictional disk, and these features are made for lubrication and to decrease the friction between parts. In the next video, if Allah wishes, I will design this part, and also it's not very complicated. It will be simple part if Allah wishes. Thank you for watching, and wait the next tutorial. Thank you. Welcome to Marzoon SolidWorks Tutorials and Designs. Today we will continue to design this robot parts. We designed all the parts of axes 5 and 6, and now we are designing and also the parts of axis 4, and today we are starting to design the first part of axis 3. We are going to design this part. We designed this part in the previous video, and today we are going to design this part. Now we will take a look about this axis. I think it's the most complicated one, or the most axis to have movable parts like this. But it's very beautiful. And we will learn how to design all these parts. We started with this yellow part, and today we are going to design this part. It looks to be complicated, but it's very simple. Okay, how to design this part? I just want to move axis 3. Okay, no problem. We will go back to this later, but now we are trying to design this part. How to design this part? I will open a new part, and on the front I will draw this sketch. This is the sketch, and I will try to add some dimensions. This is 27, this is 17, this is 1, and this 3, and these 4 lines are equal. Again, there is 2 lines there, and I will trim this. This line is 3, and this line is 200. This line also equal this line, and this is 2, this is 10. Now I will add some diameters. This diameter is 300, this diameter is 104, this diameter is 260, this diameter is 86, and this one is 72, this one is 95. Okay, we will have some relation. This point is coincident with this line. This line is 18. I think this line, okay, yes, this line needs to be horizontal. There is a question now, how did you discover this problem? To discover such a problem, just search for a blue point and move it. Just search for a blue point like this and move it, and you will discover the problem. Okay, now this sketch is fully defined, and I will make a revolve about this center line. Okay, and I will save this part as let's call it axis 3 hub. No problem about the names. Okay, and I will save this now. Okay, this is the first feature. The second feature, I will go to the front, and the second feature is on the top. Okay, I will go to the top, and I will draw this center line here. The distance between the origin and this center line is 76. Okay, starting from this center line, I will draw this profile. This relation, we don't need this relation. Again, I will continue. And I will close this profile. I will add some dimensions. These 3 lines and this line are equal, and any of them are 1 millimeter. This is 3, and this is 13. Okay, this line is 4, this line is 32. Now I will add some diameters. This diameter is 55, this diameter is 40, and this is 128. Now this is fully defined. I just want, okay, now again I discovered the problem. I just moved a blue point. Again I will make a revolved cut of this about this center line, and I will make mirror about the front plane of this feature like this. Now looking from there. Okay, again this was the first feature, this is the second feature, and this is the third feature or the mirror. Okay, Now on this face I will make a circle with diameter 120, and I will make this vertical line or these two vertical lines, and I will trim these lines. I will make tangent between these two lines and tangent also between this line and this circle. Now the profile is fully defined. I will make extruded cut up to this surface. Okay, like this. Okay. On the front plane I will make center line like this, and this distance is 72, and I will draw this profile. And I will close the profile. I will add some dimensions. This is 1, and again these 3 lines and this line are equal. This is 4, this is 12, this is 15, and this is 3. I will add some diameters. This is 68, this is 56, and this is 42. All these diameters are for bearings. This 68 and this 42 are for bearings. Again I will search for the problem. Again it appears that this line needs to be vertical and this line needs to be vertical. Okay, again I will look or search there. The distance between this line and this line is 70, and this was the missed dimension. And I will make a revolved cut. Notice. Okay. Again I will make mirror about the top plane of this feature. Again this is now how is the shape. Again on this face I will draw a circle, okay, and this line here, and I will trim all of this, and I will make a fillet there. The value is 40. Okay, I will make this line to be center line, and I will mirror all this about this line. This is 120. The distance between these are 60, and this is 100, and this is 300, and I will make a center line there, horizontal, and I will make mirror of all this about this, and I will make extruded cut starting after 20 millimeters like this, and the depth of cut is 20 millimeters like this. This is the hole. Okay, again I will make on this face a center line with 136, and this is a circle of 14, and I will make a cut with 20 millimeters. Now I will make circular pattern of this feature about this cylinder, and I will skip this hole and this hole. The number is 20. Okay, again I will skip this 3 holes and this 3 holes. Okay, this is the result. Again I will continue on this phase. I will draw this circle 244 and these two circles 138 and another equal this equals this. Okay, and I will trim these two circles and these two arcs. Okay, and I will make extruded cut by 2 millimeters, but I will flip the side to cut the outer area like this. Now I will make a fillet of the value of 20 on these 4 . This fillet is just for the machining tool which will go there. It must have a fillet. Now on this face I will make guiding holes like this, 2 guiding holes or 4 guiding holes. And the distance, the vertical distance is 168 and the horizontal distance is like this, and the depth of cut is just 10 millimeters. This will carry pins just for guiding like this. On the other face here I will make slot, this type of slot. I will add dimensions. This is 80, this is 40, and this angle is 90. And I will make a center line between this and this and make this center line horizontal. Now I will make a center line horizontal here, and I will make mirror of this about this, and I will extrude this by 40 millimeters like this. I will add fillets, 5 millimeter fillets here and here and also here. Okay, again I will repeat this here and here like this. Or you can don't add this fillets. The last thing is that I will add a hole wizard of M16. The values is 35 and 38. Okay, I will add this hole here, and I will make a circular pattern of this hole. A circular pattern of this hole about this cylinder, and the number is 16. And I will skip this 3 and this 3 holes. Okay, Going back to the main design. This is the main design. These holes will carry the friction plate of axis 4, and these holes will carry these shafts. There are 5 shafts there. 2 shafts for axis 4, this and this, and 2 shafts for axis 5 and 6. This is 1 and this is 1, and axis 4 is there. This shaft is for axis 4, and also this is for axis 6, and this sleeve is for axis 5. Okay, thank you for watching, and in the next video, if Allah wishes, we will learn how to design these drives. It seems to be complicated, but it's very simple. By the way, this is how this part of today, how this part is assembled to this part. On these holes there will be studs, and these studs will carry or will hold the blue part, or the part which we designed today. Okay, again I will hide this studs and nuts. Okay, I hide these parts just by clicking on the part and clicking tab in the keyboard. Or you can just click and hold on tab and just hover over the part which you want to hide. Okay, in the next video we will deal with these drives or these shafts and gears. It's very simple. Okay, thank you for watching, and wait the next tutorial. Thank you. Welcome to Marzouk SolidWorks Tutorials and Designs. Today we will continue this design. All the previous parts are explained in previous videos, and today we are going to design this part. Or just for simplification, I will deal with this simple assembly or this sub-assembly. Today we are going to design this shaft, and this shaft is a part of this sub-assembly. This is the sub-assembly. It's a very simple sub-assembly. Before we explained how to make this part or this gear. This is module 2 and number of teeth 32, and the width I think is 30. The width is 30, and before we in the second video of this playlist you will find how to generate this gear. Again, the number of teeth is 32 and the module is 2. Again, this gear, the module is 2 and the number of teeth is 60. And this is 2 bearings. This is 6005 and this is 6006. These are 2 bearings. This is for 25 mm internal diameter, and this is 30 mm internal diameter. But now or today we are going to design this part. This is a very simple part. I will open a new part, and on the front plane I will draw this profile. These groups are for snap rings. These groups are for snap rings. This line is horizontal, and we will need a center line there. Now I will add this center lines just to make sure that this angle is 45, and again the same method there, two center lines and equal. I prefer this more than putting angle. Again I will add this relation between this line and this three line, and this three lines, and this three lines, and this three lines, and one of these lines. All of them are equal, and again this line is 1 millimeter. Now we will add more dimensions. This line is horizontal, is vertical. Now we will add some dimensions. This line is 2 millimeters, and this line and this line are equal. I prefer adding relations more than adding dimensions. This line is 3, and this line is 4. Again, now I will add more dimensions. This line is 30. To make sure, or to avoid these problems of dimensions, there are very simple method. Just put all the dimensions firstly. And afterwards you can change the dimensions. What do you mean? Again, I will explain this. This will be 30 afterwards. This will be 30 afterwards. This is 4. Or the dimension is already found. Okay. I will put this dimension now, and I will change this afterwards. I will put this dimension now, and also this dimension, and also this dimension. When you do this technique, when I change this now to be 30, there will be no problem, because all the other lines will move together. Again, this is 4, and this is 13. Again, all the lines moved. There is no problem now. This is 1, 5, 3. Again, this is 30, and this is 12. Now I will add some diameters. This diameter is 24. This diameter is 30, and this is 38, and this is 32, and this is 25. Now all the sketch is fully defined. You can go back and organize the dimensions like this. Okay. This also will help when you try to add dimensions to drawings, technical drawings. And I will make revolve about this line. Okay, this is the first shaft. It's very simple. I will call this axis for I shaft. Okay, and this is, no, I will change the name to I shaft 2 or 3. Okay, and I will close this file. You may notice that the part has the same name. This part has the same name, axis for I shaft, so the program didn't accept to make the same name again. And you will add this gears and bearings. Now I want to show you how the mechanism works. This is the motor of axis 4, and this is coupling, and this is the long shaft. We will design this shaft now. This shaft moves this bearing, this gear, and this gear moves these two gears, and these two gears moves these gears, and this gears moves axis 4 drive. Now we draw this shaft, and now we will draw this shaft. This is also a very simple part. I will open a new part, and on the front I will draw this profile. This line is horizontal, and we will need a center line there. Firstly, I will add some relations. These two lines are equal. These two lines are perpendicular. I think I will need another line there. I will trim this, and I will add perpendicular between these two lines. Now I will add some dimensions. This is 30. This is 1, and also all of this are 1. And I think here also these three lines and this line are equal. Okay, this is 30. This is 1. Okay, this is 95. Okay, again we learned how to deal with this problem before. The method is to put dimensions and don't change them. I will put dimensions and I will not change them. This is 3, no problem of changing this dimension. This is 13, and also no problem with this. This is 4, and this is 9. Up to now there is no problem. I will put this dimension, but I will not change this now. After I change all other dimensions, I will go back and change this value again. This value is 4. This value is 15. This value is 5. This is 14. You are trying to make all the dimensions defined. This is 24. Again, we will need to add some diameters. This diameter is 18. This diameter is 25. This is 29, and this is 30. This is 38. Again, we will need to move this like this. Okay. Again, this diameter is 40, and this diameter is 20. This line needs this value is 3. I think this line has another relation, which is there is a relation there. I think there is a wrong relation there. This is 40 and this is 48, but okay, this is 48. Okay, I can delete this value and add this to be 48. I will explain to you what is the problem now, or what is the cause of this problem. This line is 723. Okay, again I will delete this value and I will add this dimension. This shaft is 20. Okay, again this line is, this diameter is 20. It seems to be complicated, but again when you make this design you will understand why I choose these dimensions. All of them are related to bearings and gears. This is related to bearing, this 30, and also this 40 is related to bearing. You need a shoulder here with 4 mm, so this dimension is 48. This is also for gear. This 15 is related to the bearing, which will be mounted there. Okay, I think now all the dimensions are found in this design. So this is the design. Again we want to understand why these dimensions. Again I will close this and this. Again looking there, and we will understand that these dimensions are for this bearing, and this dimension is for this bearing, and of course this grooves are for snap rings. This is for coupling, and this is for this gear. This 1 mm is for Now if you look from there, you need this 1 millimeter to stop the contact between the gears, this gear and this shaft. You need this area of clearance. All of these dimensions are related to other parts. Again, you can understand now why did you choose these dimensions. I choose this dimension for this bearing, and you can notice that there is a clearance there. This is very important, this clearance. And again on the other side, the same idea. So you can notice that I make all of this 1 millimeter, and all of this is 1 millimeter also. So now you can understand the dimensions. And also I make this shaft, you just need 20 millimeter or something like this. This will carry a small amount of torsion, this shaft. Going back to the main design, now we can hide these parts. You know that I hide the parts which I finish, just to make the design more simple and light for my computer. Again, I will hide the parts, this part. And also I will hide this shaft and its gear, and of course this bearing, and also this bearing. This is just for simplification. And of course we didn't design this part yet, so I will show it. This, by the way, this is a very beautiful part. We will deal with it in the next videos, how to design this part. It's a very simple and beautiful part. I think the most simple is the most beautiful thing in all this design is this honeycomb. I love it very much. But the most complicated part in this design is this base. The base, I think it's very, I don't like to say complicated, but it has many surface and loft features. And also we will learn it together if Allah wishes. In the next videos I will explain this sleeve and its shaft, and also it's a very simple design. In the next videos I will explain this sleeve and its internal shaft. They are very simple parts, but the problem there, or the idea there, is how they are mounted together. This idea is found in watches. This shaft is found in watches. You have three shafts, each of them inside each other, and each of them work separately. And we will deal with this shafts in the next videos if Allah wishes. Thank you for watching, and wait the next videos. Thank you. Welcome to Robotic Tutorials and Designs. Today we are going to model or design these two parts, this sleeve and this shaft. You can notice this mechanism in many watches. It's very famous in watches. These two shafts are working separately. This yellow shaft moves axis 6, and this motion comes from this gear, and this gear takes its motion from this gear, and this gear are powered by this motor. This is 4 axis 6, and this leaf moves separately. This takes its motion from this gear and the same from this motor. Today we are going to model these two parts, this green sleeve and this yellow shaft. They are very simple. How to design this part? This is very simple. I will open a new part and I will open a sketch on the front, and I will make this profile. This line will be horizontal and this line will be vertical. I have 3 steps there. I will make this line as a center line, and I will mirror all of this about this. I will add perpendicular between these 2 lines, and I will make a center line for diameters. This diameter is 18. This diameter is 24. This is 18, and this is 12. I think they are okay. They are just 2 steps, not 3. Again, I will delete these 2 lines, and also, by the way, when you delete these lines, make sure that this line will lose all its relations, and this is sometimes make problems for some designers. You can, if you understand that this problem happens, you can deal with it. You can just go and solve the problems of these lines which has no relations. Again, I will add a chamfer there. Just by 1 millimeter there, and also there. Okay. Going back and adding dimensions, this distance is 16. This distance is, I will leave this now. This distance is 5. And now I will make this 20. Why did you make this? Just to make sure that the dimensions will not make any problems, and the dimension between these 2 points are 275. Now you can notice that all the sketch is fully defined. This is a very simple shaft, and I will make a revolve about this line. Okay. The next thing that I need to add cosmetic thread. If you don't find this command there, go to commands and set it for commands. Go to search and set it for commands, and search for cosmetic, COSME. This is the command, and this is the command there. I will choose this edge, and that size is M12, and up to next. Okay. Again, in the other side, I will add the same M12, up to next. Okay. If you noticed that there is no command for thread there, just open the shaft which carry the thread, even it is extrude or revolve. Even this is extrude of a circle or a cylinder, you will find the thread inside it, or a revolve, you will find also the thread inside it. And I will save this part and exit. Let's call it axis 6 shaft. The other part is also very simple, but there is a problem there. It's not a problem, but there is a trick there, that this distance is not equal to this distance. So how would you deal with this problem? I will make such a simple method to deal with this problem. This is a trick. How could you make this? I will open a new part, okay, and I will open a sketch there. I will make center line there and center line there. For this center line, I will make the parts till this area or this edge, from here to here, and will mirror it in the other side. Okay. This part contains a very good trick. And I will stop there. Okay, and I will mirror all of this about this line, and I will add all dimensions. This line is 60, and also this line is 60. Or you can add collinear between these two lines. This line is 68, and this line is 18. These two lines are perpendicular. Now you don't need to add angles. This distance is 140. Okay. This distance is 18, and all of this and all of this, all of this are equal, and the end of them are 1 millimeter, and this value is 5. Now I think the sketch is fully defined. You just need to add this diameter. This diameter is 58. Okay, here is the trick. Now I will add a line there which is 2 millimeters, and I will add another line there which is 21, and I need to draw the next dimensions. This is a sketch. I need to add this part and this part. If I draw in this part from there, they will be mirrored in a wrong place. How to make this? I will start there, from there, and will make this line, and I will continue like this, and I will make, here is the trick, I will make a center line there in any place, and I will mirror all of this about this. Now just moving this line will move this part. Now I will add a merge between these two lines, and notice that this line is now blue or underdefined. Now I will add a relation there. Now this line is fixed. Okay, and I will add the other dimensions. This diameter is 52. This diameter is 48, and this diameter is 40. This dimension is 30, these three lines are equal and any of them equals any of these lines. Okay, this value is 3. Of course, you notice that this dimension changes in the other side. Of course, this changes in the other side because there are a mirror there. Now I need to add the last line between this point and this point. This closes the contour, and now I will add this diameter, which is 31, and this diameter, which is 25, and now the sketch is fully defined. I love this trick. It's a very beautiful trick. Okay, I just revise the dimensions. Okay, now I will add revolve about this center line. Okay, and we will have this sleeve, and we will save this as axis 5 sleeve. Like this. Okay. Again, we explained before how to design this timing pulley. So I will hide this, and this is a nut. You will find it in the files. By the way, you need this clearance. Again, I will take a section like this. You need this clearance. Why do you need this clearance? Just because when you close this here, you make sure that this nut compresses this face, not this face. So you need this clearance. Again, I will hide all these parts which we drawn already. Of course, you will find all these gears, and I explained before how to design these gears in video number 1. This is module 2 and number of teeth 48, and this has 2 configurations, and I explained before how to make these configurations. You will find this configuration method in the video of timing belts or timing pulley. We draw this and this. Of course, you will find how to make also these bearings in video number 2. I just try to simplify the design. In the next videos, we will explain how to design the next parts. Thanks for watching, and wait the next video. Thank you. Welcome back to SolidWorks tutorials and designs. Today we will continue to design this robotic arm. Today we will design this part. It's a very simple part, and now we will learn together how to design such a part. I will open new part, and I will open a sketch on the front, and I will draw the profile of this shaft. I will need a center line there for the dimensions. I will make the main dimension. This dimension is 172. This dimension is 12. These three lines and these three lines are equal, and every one of them is just 1 millimeter. This is 6 and this is 30. This is 2, and the dimension from here to the origin is 110. This dimension is 15. This dimension is 1 and this dimension is 3, and now the dimensions are all located. Now I will add this diameter. This is 20, this is 28, this is 40, this is 48, this is 40, and this is 20. I think that there is a problem there. Yes, this line is vertical and this line also is vertical. Now the dimensions or the sketch is fully defined. Now I will make a revolve of this part. Okay. Now I will try to make the spline shaft there. It is not gear, it is a spline shaft like that. The spline shaft is used as K or multiple Ks. On this face I will draw center line and 3 lines like this, and I will make mirror of this about this, and I will add dimensions. This is 2.5, this is 1, and this is 2, and I will draw the path. On the front I will draw just line like this and arc like this. I will add a relation between these 2 points, and I will add the dimensions. This is 8 and this is 32. Now I will make swept cut. This is the profile and this is the path. Okay, make sure that the cut don't collide there, and I will make a circular pattern of this feature about this cylinder, and the number is 16. It's a very simple design, but we will need two types of this shaft. Again, looking from there, we will need 2 shafts of this. This is one and this is the other. Easily I can make configuration of this dimension, right click and configure dimension. In the other configuration I will name it as configuration number 2, and I will change this to 38 millimeters. So I have 2 configurations like this. They are the same, but the only difference is in this dimension. By the way, we will mount this gear there, and this may need some pressure or compression or using a hammer or something like this. So I don't need to harm this area. So I will make a very simple technique there. I will make this diameter you can say if this is 28, I will make this 27.8, but firstly I will need to remove this equal relation, and I will add a new dimension there. This will be just 27.8. This will help when I put the gear there. I don't need to make interference with this face. Looking from there, now there is a clearance between the two cylinders. By the way, this will be applied in the both configurations. Also there, you will find that this will be 27.8. In the main design, this is gear which is module 2, number of teeth 24, and this hole is 28, and this bearing is 6004, and this bearing is 6008. I will hide this now. By the way, this spline shaft will be inserted in this part. In the next video, if Allah wishes, I will explain how to design this part. It's a very simple part. So I will hide this part. We used to hide parts which we actually designed, just to simplify the design. In the next video, if Allah wishes, I will explain how to design this universal joint or Y joint. It's a very simple, and I think it will be a beautiful tutorial also. Thanks, and wait the next tutorial. Thank you. Welcome back to Marzo's SolidWorks tutorials and designs. Now we are designing this robot, and today we will learn how to design this universal joint. The first part is this spider. It's a very simple part. I will open a new part, and on the front I will draw this rectangle 18 by 18, and I will make extrude 18 and mid plane like this. This is a cube. Now again on the front I will draw this center line and this arc. I will change all these center lines to lines. I will exclude this center line. Again, I will make a relation between the origin and this arc. They are concentric. The dimensions are 12, and these two lines are, I will add a center line there. These three lines are equal, and any of them is just 2 millimeters, just to make the sketch fully defined. Now I will use this shape to make a revolved cut about this center line, and this will make this shape. On the front again I will make this revolve. I will need this center line. I think I will not need this groove of snap ring. I will show you now why I don't need this groove. I will make equal there, and any of this is just half millimeter, and this distance is 8 millimeters, and this diameter is 12, and I will make a center line from there, and I will make the dimension from there to there to the other side is 44, and I will make a revolve about this line to have this part or this feature. Now I will make a circular pattern of this feature about this circle just for instances like this, and I will rename this part, or I will call this part as spider. Okay, this is the first part of the universal joint. Again, going back to the main design, this is a universal joint, or you can call it cardan joint or Y joint. It is consisted of this spider and this Y bracket. This bracket also is very simple. By the way, now I can show you why I don't need snap ring in the spider. Again, I just wanted to reach this assembly. Here you can notice that I don't need snap ring there, because there are two snap rings there and there, so these bearings will not go out, so I don't need snap rings there. Now I want to design this part. It's also a very simple part. Now I will explain how to design this part. In the front, I will draw this shape. Now I will add some dimensions. These three lines are equal, and any of them is just 1 millimeter. This is 2 millimeters. This is 4. This is 8. This is 2. Or I can say that this and this and this, all of them are 2 millimeters. I will make mirror of this shape about this center line, and I will add a dimension from there to there to be 44 millimeters. Again, I will need a center line there just to determine the diameters. This diameter is 28 millimeters. Now these dimensions are fully defined, and I will make a revolve about this line. This is the first part. The second part will be, again I will need a center line there. The second shape will be something like this. I will make mirror of all these lines about this line. Now I will add some dimensions. This dimension is 2. This dimension also is 2, or I can add center line from there to there and make this center line horizontal. This will determine that this line is in the center of this line. I will add some dimensions. The distance from there to there is 50 millimeters. This dimension is 30. This is 3. This dimension is 20. Now I will add a center line from there to there, and I will make these two lines equal. Now I will make extrude by the thickness of 30 mid-plane, but the most important note there is not to merge these two bodies. Now I have two bodies. On this face I will make a sketch and I will convert this circle, and I will use this circle to cut through just this part. Now you can notice that I used feature scope and this circle just went through this part. Okay, so this part became like this. Now I will combine these three bodies. From direct editing I will add combine, add these three bodies to be one part. Now we will need some fillets. Firstly, you can add fillet there. I will choose them manually, there, and there. This fillet maybe 20. We may need chamfer by 2 at these edges. It's a very simple steps of filleting and chamfers. Now we can add fillets of 3 there. We can add fillet of 5 there and there. We can also add fillet there and like this, 4 there and there. It's a very simple combination of fillets and chamfers, and they are not important. The important thing now is to make the hole there. You can remember that the shaft which will be located there is 20 millimeters, and it will be through hole. And again, the teeth which will be there was like this, or the holes. Again, I just want to go back to see these dimensions. We designed a similar thing like this. I think the inner circle was, let's say, 16.5. Okay, again, now this dimension I will make this 16.5, and I will draw the teeth. This is center line, and this is also center line, and I will make an arrow of this about this. I just want to make sure that there is no relation between this line and this origin, like this. Okay, the holes of course will be like this, and the dimensions will be this was, I think this was 2, and this was 1.5, and this was 2.5, and this was, I think, 8, something like this. And I will make through holes like this, and I will make circular pattern, the number of 16 of this, about this, the number is 16. Again, you can go back to the previous video, and you will find the dimensions, or the correct dimensions of this design. Now this is not the problem. The problem there is why I choose these dimensions, this 44 and this 28 and these dimensions. Okay, now I will show how these parts will be manufactured, or how it will be assembled. I will make assembly. Now I will save this part. Let's call it Y block. Okay, and I will make assembly from this Y block. Sorry, again, I will just close the parts which I don't use. Again, this is the part I called it Y block, and I will make assembly from this. Okay, this is the fixed part, or the first part, and I will now add the spider. Now I want to examine or test if this part will be assembled easily or not. To make something like this, I will use a very beautiful command of SolidWorks. I will use move components and physical dynamics. Okay, the meaning of physical dynamics is that when something collides to another part like this, it behaves like real behavior like this. You can see that when this collides there, it don't go through the other part. Okay, how I will use this function? I will try to assemble this part like this, like what happens like this. So I make sure that this part will be inserted in the other part. So this dimension is, or these dimensions are suitable for assembly. Now I will make this like this, and I will add a bearing from there and a bearing from there, and using the same method. Now I will make again move component using physical dynamics. Now I will move this part like this. Again, I will use physical dynamics. I think this will be difficult just on SolidWorks, but in real situation it will be very easy to insert this part or this shaft inside this this other part. Again, the most important thing there, I will just make change there in the dimensions. Again, I will change this dimension. Let's say that 44 is 34. Okay. And now I will check if I will be able to insert this part or not. Again, using move component, physical dynamics, I will move this like this. Again, like this. Okay. Now you will notice that this part will not be able to be inserted in the other part. This is a problem. Now I will not be able to manufacture this or to assemble this, but changing the dimensions. By the way, I made this design many times, not from the first time I was able to make this design. Again, I will use move component, physical dynamics. Now I will insert this part like this, like this. Again, like this. Okay. The worker who makes the assembly in the factory will make the part like this and like this, and the same with the other bracket, and we'll add the bearing there, and we'll add snap ring there. So we will get this assembly there like this. This bearing is 6001, and of course there are internal snap rings there. And again, you don't need snap rings in this spider there. You don't need snap rings there. Okay. I think this video is beautiful, and the motion of this part is very beautiful also. Okay. In the next video, if Allah wishes, I will explain how to design this shaft. Okay, thank you. Welcome to SolidWorks Tutorials and Designs. Today we are going to design this long shaft. It's a very simple design. I will open a new drawing on the front, and I will draw this profile. I think now we can understand the grooves, or why I make this profile like this. I think it became simple. And again, I made this before many times. These 3 lines and 3 lines are equal. Any of them is just 1 millimeter. This line and this line are equal. Any of them is 3 millimeters. These grooves are just for bearings. The bearing there is 40. I will make a center line. The bearing there is 40 millimeters. Again, the bearing there is 40 millimeters, and the bearing there is 30. And again, you can understand that when I make 40 millimeter bearing there, I will need 48 shoulder and their 38 or 36 shoulder. Okay, this line and this line and this line are collinear, and any of them is 20 millimeters. Now I will add some dimensions. This is 15. Again, now you can understand that this 15 came from the bearing which will be mounted there, and this is 13. This is 13. The two shoulders there are equal, and any of them is 10 millimeters. Now I will add some dimensions. This is 48 or 45 millimeters, like this. This dimension is 24, and there are still one dimension which will make all the sketch to be fully defined, which is this dimension, which is 7.6. Okay, now I will just organize the design. Again, just to make it easy to modify the dimensions, like this. Again, this is 20, this is 48, this is 40, 15, 10, 45. Okay, and I will make a revolve. Okay, like this. Again, I just wanted to look at the dimensions. Okay, and I will need spline shaft like this, and we made this 2 times before. It became very easy. Bar like this. These 3 lines will be solid lines, and I will make mirror of this about this, and the dimensions is 2.5. This is 1.5, and this is 2. This is the profile. Again, on the front I will make the path, starting from there to there. These 2 points are horizontal. This arc is 8, and this is 32. Again, I will make swift cut of this profile along this path. Again, and I will make circular pattern of this about this. The number is 16. Okay, it's a very simple shaft, and this shaft I will rename it as axis 5 and 6 long shafts. Okay, this shaft will be used to transfer the power of this motor along this distance to the universal joint in the long drive to axis 5 and 6. Again, this bearing is 6008. This distance is 15. This distance is 15, and the bearing there is 6006. Again, you can notice that this shaft will be inserted from there, and these 2 bearings will be in their positions. The biggest diameter there, the biggest diameter of this part, this must be able to go through this bearing here, and it will be able, because this is 40 and this is 36. So we will firstly mount the two bearings in their places, and after which we will put the shaft, which will carry the power of this motor. Again, I will hide the parts which we actually drawn. This, this, and this two bearings. This and this. In the next video, if Allah wishes, I will explain how to design this coupling. It's a very simple part. Okay, thank you for watching, and wait the next video. Thank you. Welcome back to Marzo's Robotic Tutorials and Designs. Today we will design the coupling. It's a very simple part, like this. It's a very simple part. I will open a new part and a new sketch there, and I will draw this profile. I will add two center lines there, and I will make them equal, and two center lines there, and I will make them equal, and I will make these two lines equal, and any of them is 3. I will need center line there to add diameters. This diameter is 20, this diameter is 12, this diameter is 36, and this diameter is 40. This distance from there to there is 10, and from there to there is 30. This line is 24, and this line is 12. And now the sketch is fully defined. Now I will make revolve about this line like this, and there I will make triangle like this, and I will add 30-degree angle there, and I will make a cut up to surface, up to this surface. Now I will make circular pattern of this feature about this cylinder, and the number is 6. Now I have this coupling. If you want to add the next or the other coupling there, it will be easy also, but I think we will not need this. I will rename this as coupling. By the way, if you want to add the other part, I just measure this distance is 12. Okay, I will make a plane. This distance is 7. Okay, and I will make mirror about this plane of this body like this, and don't merge solids like this. This is the second part, and now from direct editing I will make move copy body. I will move this body. I will rotate it about Okay, sorry, I need a line firstly, just to use it as axis of rotation. Again, I will make move of this body about this line using just 30 degrees like this. By the way, the distance was 12. The half of this distance is 6, but I made this plane at 7 just to have this clearance. If you wanted to control this clearance, I can make this 6.25. This clearance will be just half a millimeter. But I think all these steps are not important. You will easily in the assembly you will add the other part of the coupling. Like these two parts there. Okay. In the next videos I will explain how to design the motor and the rotor. This is the rotor and this is the body of the motor. By the way, in the body of the motor I made an application for a design table. It will be important tutorial. It will explain how to make design table in SolidWorks. So with the next tutorial, and we will learn together how to make such a design table. But in the part or in the tutorial of the rotor, I used another technique. I used simple configurations like this. I have 4 configurations. I made them with 2 methods. In the motor or in the body of the motor, I used design table, and in the rotor, I used simple configurations. They will be 2 important tutorials if Allah wishes. So thanks for watching, and wait the next tutorial. Thank you.